you can see some snow falling. But now here is very, very rare. You have, if you, well, I saw a video
close to the ocean
that did a cowboy from here, from un gaucho, when we have really cold weather, and he took with his hands a snake that was frozen.
Oh,
you know.
Oh.
for the snake, but it was frozen because it was really, really cold. And well, it's like
a popsicle.
No, that was kind of. And I remember in those days I went with my friends to do some pictures in the river place here, so it was really cold.
Wow.
It was like nice cutting your face or your hands now.
Yeah.
Are you getting ready to broadcast?
We're doing it right now. Yeah. Yep. Let's see. Let's see.
So David,
Yeah,
I'm giving your book a plug tonight. I even have a picture of the cover in my talk.
well, is that me,
Isn't that
David?
nice? Yeah. That's
Yes, your
Well,
Galaxy book.
Oh, thank you. Well, how should I make out the check?
Lots of zebra.
Okay. Thank you, Mike. That is very nice. Thank
Oh, it's a great book. I love it.
you. I appreciate that.
As 2022 is dawning, the European Space Agency readies itself for another year filled with exciting missions, new milestones in human spaceflight, and cutting-edge science. At the end of 2021, the long-anticipated James Webb Space Telescope was launched from Kourou on top of an Ariane 5. This new space telescope is a partnership between ESA, NASA, and CSA. In 2022, during the first 5 months of the telescope's operational life, the data from the Early Release Science Initiative will be sent back to Earth. This data will be made available immediately, providing the entire scientific community with early access. Another look at our universe will come from the full Gaia Data Release 3 in the first half of 2022, adding to what is already the richest star map of our galaxy and beyond. Closer to home, Solar Orbiter will get within a distance of 50 million kilometers to the Sun for another close pass in March. This will offer a significant boost to the science that can be done, and a plethora of new data is to be expected. In the future, Solar Orbiter will also provide scientists with the first good look at the Sun's polar region. For science, the planned launch of ESA's ExoMars 2022 mission will be another milestone, sending the European rover Rosalind Franklin and a Russian surface platform to the Red Planet. Looking for signs of past life, the rover is the first mission to be able to roam across the planet and drill down to a depth of 2 meters into the planet's surface. The launch and early orbit phase of the mission will be spearheaded from ESA's main control room at ESOC in Germany, and is bringing together expertise in mission control, deep space communication, interplanetary navigation, and flight dynamics. In Europe, a combination unique to ESA. In human spaceflight, German ESA astronaut Matthias Maurer will return to Earth after his 6-month Cosmic Kiss mission on board the ISS. By then, Matthias will have supported many experiments from orbit, advancing our knowledge in areas ranging from human health to material sciences. The end of his mission might even have a bit of an overlap with the new mission of his fellow ESA astronaut, Samantha Cristoforetti. Samantha will launch to the ISS in the spring of 2022 for her second long-duration mission on board the ISS. Her first mission, called Futura, made her the first Italian woman in space. Both Matthias and Samantha can only be seen as a source of inspiration for the new class of astronauts ESA will be introducing in the autumn of 2022. These new astronauts will have been selected from a pool of over 23,000 candidates who applied in 2021. In addition, ESA is planning to select an astronaut with a physical disability for the Parastronaut Feasibility Project. The selected astronauts might even become the first Europeans to set foot on the Moon, a goal ESA aims to achieve before the end of the decade. To make this ambition a reality, ESA continues to work closely with NASA on the Artemis program by providing the European service modules which are integrated with the Orion capsules. The uncrewed maiden flight of the new spacecraft Artemis 1 is scheduled for later this year, while the preparations for the crewed Artemis 2 continue. Another step closer towards a first European step on the Moon. Europe's lightweight launcher Vega C is also poised to make its inaugural flight in 2022. Launched from Europe's spaceport in Kourou and taking over from the original Vega, Vega C will be more powerful and have a larger and more versatile payload capacity. Meanwhile, preparation for Europe's new heavyweight launcher Ariane 6 continue in anticipation of the rocket's maiden flight. Both new launchers are important for ESA and Europe to maintain independent access to space. Whereas the exploration of space, the planets in our solar system, and the Moon are all important, the exploration and observation of Earth is of equal, if not of even greater importance. In 2022, ESA continues the development of a new generation of Earth explorers, such as FLEX, Biomass, and Earth Care, to better understand and monitor our planet. ESA also continues to collaborate with the European Union, developing 6 new Sentinel satellites for the Copernicus expansion missions, adding to the largest Earth observation program in the world. Another satellite soon to be observing our Earth from space is the first third-generation Meteosat that is to be launched from Europe's spaceport in 2022. This geostationary weather satellite has been developed in cooperation with EUMETSAT. Protecting our planet also means scanning the heavens for potentially dangerous asteroids, a task for ESA's new Fly-Eye telescope, which will be assembled and tested at the Assi Matera facility in Italy during the year. In 2022, ESA's Directorate of Telecommunications and Integrated Applications will continue to support European industry to innovate and succeed in the highly competitive global market for telecommunications satellites by offering its expertise, experience, and its reputation for reliability. It also develops space-enabled connectivity through next-generation 5G connections. ESA remains ambitious as ever. The intermediate ministerial meeting in 2021 was a milestone on the road to the European Space Summit to be held in Toulouse, France, in February 2022, ahead of ESA's next council meeting at ministerial level later in the year. With the need to accelerate the use of space and make space for Europe, ESA has a responsibility towards all citizens in Europe to make them part of the future of space and to align this future with the digital and green transitions.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and I'm very pleased to present the 98th Global Star Party to you. The theme is exploration and awareness, and one of the things that the aspect of awareness is, or awakening, I'm sorry, is that after watching a documentary about the overview effect from astronauts that had experienced the Earth rising off of the horizon from the moon. They had a shift, a cognitive shift, as they called it, but they saw the thin layer of the atmosphere of the Earth and experienced how frail the Earth looked from space. And of course, you don't see any boundaries or any of these things, no separation. It's just this glowing, living orb that's out there in the vastness of space. And it changed these astronauts forever. But I'll argue that people that experience astronomy and see amazing things like the rings of Saturn, a comet blazing across the sky, or in the case of where you see kind of the dance of the solar system, a total eclipse of the sun. You can also have these kinds of experiences right here on the spaceship Earth. And so, this aspect had captured my imagination, and I know it's something that is often reflected upon by the presenters here on the Global Star Parties. So very, very happy to present our 98th as we march towards our 100th Global Star Party that will broadcast in July, mid-July. So, to kick off this Global Star Party, we're going to turn to David Levy, who guides us through the beginning of each of our Global Star Parties here. And David, thank you so much for coming on for the 98th Global Star Party.
Well, thank you so much, Scott. And it's really such a pleasure to be here. It's an interesting theme today. We're talking about not just the cosmos, but about the cosmos's relation to us. And we all have relatives. And we all have brothers, sisters, parents, grandparents, grandchildren, nephews, and nieces. But one of the relatives that we should not forget is the cosmos itself. Because as large as it is, and it is the biggest thing that there is, it also is extremely personal, and it's very personal to me. And especially how we view it, how we see it. And so for my quotation today, I'm going to quote from William Blake's Auguries of Innocence, published in 1803. To see the world in a grain of sand and a heaven in a wild flower, hold infinity in the palm of your hand and eternity in an hour. Thank you, and back to you, Scott.
Very appropriate poem there, David. Thank you so much.
Thank you.
Let me find my little thing here. Here we go. I'm back, and that's great. So you said that you were getting some rain here. This is the day of the equinox, right? Or the solstice, excuse me.
It's the
Summer
solstice.
here, and it's winter down under. So, but
And we are getting some rain, not much, a little bit of rain as
little
we
bit of
start
rain.
the summer of 2022 today.
well, we are having a classic summer day here in Arkansas. So it's blazing hot outside, is over 100, and so I'm looking forward to it cooling down a little bit as the evening wears on. So thanks again, David. Okay. All right. So we always bring the Astronomical League on to the Global Star Party. They have been with us for most all the Global Star Parties that we've done. The Astronomical League is the world's largest federation of astronomy clubs. They have over 300 clubs under their umbrella, over 20,000 members that call themselves Astronomical League members, and they have incredible observing programs, an incredible and amazing awards program, and they are heading towards their next Astronomical League conference, which will happen this July. So I'm very excited to be attending myself, and so we will be broadcasting live some of the talks and lectures that will happen or actually the topics of those talks and lectures at the Astronomical League. To actually see them in their entirety, you're going to have to be there. And so that's a great reason to go to the Alcon event, which will be in Albuquerque. But for now, I'm going to turn this over to Don Knabb. Don will ask and he'll talk about the Astronomical League questions that are asked for the door prizes. He'll talk about who the winners were, and he'll ask the new questions. So Don, I'm going to bring you on here.
All right. Can you see and hear me okay?
Absolutely.
All right. Let me share my screen then. That would be this one. Then I will go to slideshow. Okay. We always start with a warning about proper observation technique for seeing the sun. A terrible way to go blind would be to look straight at the sun. And you may remember last month I was on, I mentioned and held up the issue of astronomy from the spring where Bob Berman wrote about solar safety. So it's important that you never leave a telescope unattended in the daytime. You have to use the right filter at the top of the telescope, not in the eyepiece, because it would melt right through the eyepiece filter. And always consult with a knowledgeable observer before you attempt to observe the sun. And in fact, in this current, the quarterly issue of The Reflector, the Astronomical League magazine, there is a full article about how to observe the sun safely. So, we take it really seriously. We don't want anyone to go blind. There are much safer ways to see the sun than doing anything that you shouldn't be doing. So always do it the right way. But this is a great article, by the way, about solar observing. So from June 14th, answers. What space mission was on? So if you were looking at this, you could see the Apollo lander and the Surveyor spacecraft, Surveyor 3, and that was Apollo 12, okay, from 1969. They landed only 600 feet away, so the astronauts could walk to it and get samples. And interestingly, samples of bacteria from Surveyor's cameras prior to launch were detected, had lived on the moon or had survived on the moon for 31 months. So that was Apollo 12. First person to apply for a patent on telescope, Hans Lippershey. Okay, he is generally credited with inventing the telescope in 1608 and applied for a patent. He applied. We didn't say he got it. So he was denied because of another spectacle maker, Zacharias Janssen, invented the telescope first. No one really knows. But either way, Lippershey did get compensated for binocular telescopes he made for the government. So the answer was A, Hans Lippershey. And third, and this one took me some digging to figure out, structure was discovered in 2020, the nearest coherent gaseous structure in the Milky Way, responsible for the apparent break in the bright band of the Milky Way in the direction of Perseus. It is called the Radcliffe Wave. That was a new one to me. So 8,800 light year long interconnected band of molecular clouds, which are stellar nurseries, named after the Radcliffe Institute in Cambridge, Mass. So the people with the right answers were Cameron Gillis, John Williams, Israel Monteroso, Andrew Corkill, and I got them right too. So there. Okay, now the questions I came up with for this week. And we'll go through them. Okay, here we see a picture of a satellite from NASA. So scientists have begun to announce the first results of analysis of the material from asteroid Rygu. So the question is, what spacecraft brought this material to Earth? Okay, what spacecraft from NASA traveled to Rygu, picked up samples and brought it back? Was it the Juno spacecraft? Was it Sentinel-6 or Hayabusa 2? And as always, send answers to secretary@astroleague.org, and I think we'd like to have them in within the next couple of days. Okay, so Juno, Sentinel-6, or Hayabusa 2. Messier 18, a nebula nicknamed the Pillars of Creation. And here's a photo from NASA. I think this was taken in infrared, if I remember right? Another name for this nebula. Okay, we call it the Pillars of Creation. What else is it called? Is it the Eagle Nebula, Trifid Nebula, or the Lagoon Nebula? Okay, Messier 18, the Pillars of Creation. An amazing sight. And lastly, historical astronomy here. Johannes Kepler, a German astronomer, mathematician, astrologer, and natural philosopher. Best known for his laws of what? Universal gravitation, planetary motion, or chemistry. Johannes Kepler. And this is a historic image I found, and go to Wikipedia. So we'll see the guy for universal gravitation, planetary motion, or chemistry. And again, send your answers to secretary@astroleague.org. And here's the another reminder of the Astronomical League Live in August. This will be after Alcon. Alcon is July 28 to 30. And then Friday, August 12th will be the next Astronomical League Live. I think that is all I've got, Scott.
That's all you got, huh?
Mm-hmm.
Well, I found some of the answers there pretty incredible, especially the one about bacteria on.
Yeah, amazing.
Unbelievable.
Live,
Unbelievable. So
alive in the moon, yeah.
Yeah, fantastic. I think there's some tardigrades up there too, right? So
There
maybe
probably are.
We just can't stop messing with things, can we?
Nope.
Anyhow, thank you so much, Don. It was great. It was great. And you will be at the Alcon event yourself?
I cannot make it to Alcon,
Oh,
unfortunately.
you cannot? Okay. All right.
Next year for sure.
Okay. Well, great. Well, I hope that some of the live stuff that we share from Alcon that you're able to tune into. So
I'll be watching.
Yep, great. Okay. So up next is, we live on this spaceship Earth, and it's got some pretty amazing stuff here. We have discovered that there is life in the universe. It's right here for sure. And it's got some pretty interesting materials on it, like minerals and crystals. And that has been the ongoing series from David Eicher from Astronomy magazine. So I always find his talk about his minerals and crystals fascinating. They're beautiful. And, if you are at all inclined to collect these things, you're definitely going to want to listen to David talk about them because he knows a lot. David, so I'm going to turn it over to you.
Well, thank you, Scott. And I will share my screen once again. We'll see if we can get a PowerPoint up here, and we'll see if we can start a slideshow. And then we will look at even more minerals. We're almost starting to run out of things, and I apologize again because I photographed these in groups on shelves. So we're getting into less organized groups. There are some things that are kind of unrelated, but they're all, I hope, somewhat interesting. And we're looking at planetary geology here. We're looking at the way the universe likes to make planets. It's a universe of order. As we've discovered more and more about the cosmos, we understand that it follows the rules and laws of science, and that we're not in the center of everything. I hope that's not a shock to anyone. And we're less special than we believe, but there's chemistry and matter throughout the entire universe, and it follows the same principles everywhere we go. We know that through spectroscopy. We only know of one place in the universe where there's life, but you know, the odds are pretty good that we're not the be all end all for that. So going back in time, we have Thomas Jefferson saying, "I believe in a divinely ordered universe." Isaac Newton, even before that time, said, "Truth is ever to be found in the simplicity and not in the multiplicity and confusion of things." The universe is ordered not by supernatural design, but by the principles of physics and of science. Minerals demonstrate that. We don't need magic to explain things. We need to actually understand what's going on. These are atoms that assemble in precise ways by their electrochemical attractions, inherent properties of the atoms that make them up, and guide them into assembling in what mineralogists call a specific crystal lattice. So here are some more examples of other kinds of minerals. And today we're looking at things that involve nickel and carbon and some other stuff. That's about as specific as we could get today because of the way that the things are grouped here. So I chose one. Nickel often colors minerals a vivid green color, where it's a chromophore, as mineralogists call it, a coloring agent. One interesting such example is called anabergite, which is nickel arsenate hydrate. It was named by Henry Brooke and William Miller in 1852 after one of the type localities for this mineral, Annaberg, Saxony, Germany, which hosts a huge number of species of minerals, including a lot of silver minerals. The colors of this mineral, anabergite, are usually green and usually a fairly vivid or apple green, can be light gray to bright green, white, or even pale rose. It's a member of the Vivianite group, and it's often found as a green alteration coating on other kinds of nickel minerals. So these are somewhat unusual minerals, the nickel stuff, and reasonably usual in the case of carbon, which is pretty common. So here's a crystallographic diagram of anabergite showing nickel, arsenic, oxygen, and hydrogen atoms sticking together there. It's in a monoclinic crystal system. And we'll just look at some examples of things. Here is a specimen of anabergite, and you can see it's the very vividly bright green stuff here that forms sort of tufts of crystals here. This is a Greek specimen from a fairly well-known mine for nickel minerals in Greece, near Attica, back near that birthplace of that concept that we all used to follow in the old days, democracy. Here's another, sorry, what, Scott?
It's fine, it's good.
Okay, I'm trying to limit my remarks here toward science for the most part.
Okay.
Here's another example of anabergite. You can see the little spheres that are bright, vivid crystal green as well, with some lead and other minerals, mimetite, a lead mineral, and others from the same mine, the 3 kilometer mine in Lavrion, near Athens, relatively near Athens. This is another unusual nickel mineral, nickel carbonate called gaspiite. It comes from Australia. And again, you can see this same kind of vivid green color from the nickel atoms here. Here's yet another one. This is nickel magnesium silicate hydroxide, napuite from, of all places, New Caledonia. If you have to swim out and get these specimens, they're really valuable, but fortunately in the modern times here, you can get them at mineral shows. But this is a very unusual nickel mineral as well, but you can see this sort of general similarity of some of the nickel minerals in their coloration. Here's nickel carbonate hydroxide hydrate, xeratite, which is another Australian specimen here with that same similar kind of greenish color. This is sort of a little tiny aggregates of microcrystals here. Not so fantastic in terms of the crystallography here, but is an unusual mineral. Then we get into something that comes from the old Lincoln country in Kentucky. Here, millerite, which is a simple nickel mineral, nickel sulfide, and it forms along this US 27 as a very famous highway that goes north and south. It goes through my old hometown, in fact, of Oxford, Ohio, right down through Kentucky and toward Florida. In the old days, it was an important road before the interstate system was constructed. And you can see this millerite, which is a fairly unusual thing, even though it's simple chemically, forms these little hair-like silvery needles. And those are the things that are in this quartz geode here that you can see. Mm. Then we can move on to carbon simply because they happened to be on the same shelf with groups of photos. Here's a diamond, and essentially all of us have diamonds in our lives, mostly with ladies we're associated with. This is a little bit more than a carat, a yellow octahedral crystal. Most diamond crystals are octahedrons, naturally. And this is from a famous mine, the Premier mine in South Africa. And it's a fairly common thing to have yellow colored diamonds as well. There's a much more famous diamond, the largest diamond in the world, that was split into several pieces. You can see it in the Tower of London from the same mine that includes the Cullinan one and other diamonds. They're a little larger than my specimen though. Now, I don't know if you can see a little whitish oval crystal that is just to the right of the center of this image in the rock here. This rock is a very, very high temperature volcanic explosive rock that shoots up and forms these pillars underground, and it's called kimberlite, a very rare kind of volcanic explosive rock, and it's the matrix that holds most diamonds that form on Earth. Diamond, remember, as we talked about a year or two ago now at this point, sorry for beleaguering you with this much mineralogy, but diamonds were actually one of the first dozen or so mineral species to be known in the solar system. They're very, very old. They're simple. They're simply carbon chemically. But it's rare to have diamonds that are in a little chunk of kimberlite. This is a somewhat rare thing. It's a Chinese specimen, mainly because diamond companies, mostly De Beers in Southern Africa, have monopolized the diamond market for so long, and they don't want natural diamond specimens to get out of there. They want to find all the diamonds, crush them, process them, and sell them to everyone who wants to get married in the history of the universe. So it's hard to get a diamond that's in its natural matrix, but this is an example here. And here also, if you see a rock, quote unquote, a little pebble also right of center here, but that's light colored and sort of angular in the way it's oriented toward us here. This is a rock from Brazil, from another famous diamond and other minerals rich area called Diamantina, in the state of Minas Gerais in Brazil. And this is a diamond in conglomerate that is found this way in riverbeds and eroded out of ancient kimberlite pipes that are very, very old. So those are a couple of examples of diamonds that are in their matrix rock still that are somewhat unusual here. This is another unusual mineral. It's a native element. You want to be careful around this, of course. This is about 5.5 centimeters across here, this piece, and that's probably enough arsenic to take out the town of Waukesha that I'm sitting in here. So you got to be careful with this, because some minerals, as we know, some of which are actually inside our bodies in very small quantities, including arsenic, are very, very toxic if we take more than we should have in our bodies within. And so it's some of these things you have to be very careful with. Arsenic is extremely poisonous, of course, but it is an important native element. This is an old German specimen that came with labels going back from a promoter of mineral specimens and mineral collecting, the Freiburg Academy, that goes back to the 18th century here. Here's another arsenic mineral, a fairly common one, but not quite so common in nice crystals. This is the, sort of rust-colored gemmy crystals here called orpiment. That's arsenic sulfide, and this is from a Peruvian locality here, a fairly common arsenic mineral, but nice, pretty crystals of it here. Here's another oddball thing. This is hard to even call this a mineral practically. It's manganese carbonate with a little bit of other contamination. But this is an unusual oddball one too from this weirdo shelf because it's a ferromanganese nodule that is from the ocean floor, from a position south of Hawaii. And the ocean floor, of course, is littered with trillions of these things. This is a fairly small one, but to recover them and have one in your collection is kind of cool because it came from a long way down. Now, here are just some other unusual things that happen to be in the same group here. Senexite, named after a famous mineral collector and mineralogist, is a copper mineral. The green here comes not from nickel, but from copper. And this is a somewhat rare mineral from Chile here that is a copper and molybdenum in this mineral. That is molybdenum is a fairly unusual elemental component of minerals. Rhodonite here, the gemmy reddish crystals here, manganese, iron, magnesium, calcium, silicate. The red color here coming from manganese, the element. This is a very good locality for finding rhodonite crystals in Australia here, called a region called Broken Hill. And there's this silvery galena, which is lead sulfide along with it as the matrix there. Now, if you don't believe that nature can do some pretty cool things, bornonite, named after a French mineralogist, is lead, copper, antimony sulfide. Antimony is another somewhat cautious element in terms of safety in that it's pretty poisonous. But this is pretty neat because bornonite from these Bolivian and other localities forms these crystals that look like little gear teeth. Here you can see the shape of this crystal, and you can imagine this turning in an engine and operating as a gear, which is pretty cool here. Here's another oddball one. These are all practically unrelated to each other, these last ones here. Cobalt keratnagite is cobalt arsenate hydrate, and the cobalt gives you this very strong and attractive purple and pink colors here from a Moroccan locality. Stibnite, here's another fairly toxic mineral here. This is antimony sulfide. And there have been recent finds in China of stibnite crystals. This is a sort of a hand-sized specimen here, pretty good size. But there are blades of this stibnite that forms these long, silvery-looking blades that are, as long as an end table here that Chinese dealers have. So this is a pretty attractive mineral, stibnite, mostly from recent finds the last 20 years or so coming out of China. I mentioned molybdenum. Here's a common molybdenum mineral, molybdenum sulfide, from a very well-known mine that's also a gold and silver mine, among other things. The Henderson mine in Colorado, of Clear Creek County, Colorado, is old gold and silver mining country there. And so that's it. It sort of was a grab bag of stuff tonight, and probably will be another few times, and then I'll get back to astronomy. And Scott, I'll mention one more time that we're going this fall to Starmus in Armenia, and we announced last week the full program of the Starmus Festival. We're going to have many exciting speakers there, astronauts, Nobel Prize winners, scientists who are at the top of their game. Our theme will be 50 years of Mars exploration since Mars 3 and Mariner 9, a little more than 50 years ago now, thanks to COVID. And we will have lots of people talking about Mars science, of course, among the speakers. We'll also have some rock and roll, and we expect to have lots of well-known rock stars who were involved in this festival here at the festival performing as well. So Scott, we're going to have a good time. Scott, you're putting on the Star Party as well.
Yeah, we definitely are. I know that you're playing a large role in this yourself with the Astronomy magazine editors who have come up with the story that will follow along with as people observe through the telescope. So it's going to be. I'm loving that, okay, because I think that is a good step forward for anybody that is involved in educational outreach and astronomy, where you've got a large group of people, you've got lots of astronomers, and so you should think about having a theme or a story so that when people leave that observing experience, they take the story with them too. So.
And we're going to have a really rich region of targets in the evening sky this fall. We're going to have everything from the moon at 250,000 miles all the way out to galaxies. We're going to take people out to M81 and M82 about 12 or 13 million light years away, and everything in between. We'll have Jupiter and Saturn and Neptune and double stars and star clusters and nebulae like you wouldn't believe. So it's going to be a good time.
Yeah, I can hardly wait. I think it's going to be great. So thanks so much, David. I get pumped every time that we talk about this. This is awesome. We're now moving on in our 98th Global Star Party. Our next speaker is Bob Fugate.
May I make a comment?
Of course.
David.
Yes.
David, excuse me. Let's try this again with feeling. David, I wanted to notice that you pointed out in your lecture on minerals that one of the first minerals you showed would have been one that Abraham Lincoln might have seen in his youth.
Yes.
Lincoln's mind would have been open to studying the minerals that you now offer. I know for a fact that he loved astronomy because of the famous story of when he knocked on the door of the Naval Observatory all by himself one night and spent a couple of hours with Asa Fall.
That's right.
President.
Yes.
But I just wanted to thank you for and bringing your real love of minerals and connecting it to your just as serious love of Abraham Lincoln. Thank you.
Well, thank you. I'll always remember that night. By the way, David, when we watched the movie Lincoln with me and my father there with you, and that was great fun. And yeah, I mean, Lincoln was one of these guys who was interested in everything. And he, there's such stories of compassion of Abraham Lincoln all the time that we forget that this guy was a very highly intelligent man, even though he had all of 2 to 3 years of formal schooling, which shows you can learn a hell of a lot if you keep reading and learning throughout your whole life. But yeah, I mean, sometime we'll have to tell that whole story, David, because when you go not to the Naval Observatory where the vice president lives, which is a great and fun experience as well, but when you go to the old Naval Observatory down at what they used to call Foggy Bottom, down in the town, that's where Lincoln visited ASAP Hall, and you can climb up that ladder. You have to, it's not generally open all the time, but if you know people, we can connect you to them. You can visit there by special appointment, and climbing up that little hatch up the ladder that Lincoln climbed. There are places where you can really, really feel history. Even though it's very distant, and that's one of them. That's a great, great story. And ASAP Hall had the surprise of his life when he didn't expect anything but to be doing his own research, and the President of the United States climbed up that ladder and said, "Hello, how are you doing?"
But it wasn't just the President of the United States. It was a man, Abraham Lincoln, who, in addition to being brilliant, was also very prone to depression.
Oh, yeah, absolutely. Yep.
Very easily talked about it. And when he first introduced himself at the to Asaph Hall, he said that I've had a terrible day. The war is not going well. And I got to tell you, I'm pretty depressed about it. And I'd like to take some time off and contemplate the night sky.
Absolutely right, David.
What a great story of the power of stargazing, to reframe your whole view of what's going on and to put all your problems in perspective, And I can only imagine the how heavily the war weighed on Lincoln during those days. So, very uncertain times. Wow. Okay. We should probably have a whole Lincoln thing sometime.
we can do a Lincoln night. We can only talk for about 8 to 12 hours.
I know that you both know a lot about him. Do you feel that he was particularly in support of science as a leader, a political leader?
He absolutely was in support of science. And not only was he was mostly in support of science because he admired those supporters of science in Congress who preceded him. One of whom was John Quincy Adams, who was an enormous proponent of science, dedicated the Cincinnati Observatory himself there, where our friend Dean Regas is now, and was the chief proponent in Congress when he was there of initiating what became the Smithsonian Institution. But Lincoln, during the Civil War, was mostly focused on his science by going and handling and testing new technologies and new Henry repeating rifles. He saw Gatling guns demonstrated right on what is now the National Mall. He went over to the Washington Navy Yard and saw new types of cannon demonstrated, pushed ahead the technology that went into becoming the Monitor that transformed naval warfare, because it was the first ironclad that could stand up to the ironclad CSS Virginia, the Battle of the Ironclads, in 1862. So he was a huge proponent of science, but mostly because of the pressures of the war, turning it toward technologies that would help not only to allow the Union to be preserved, but to transform the American Civil War into a war for the freedom of all Americans, right, as the Declaration of Independence intended.
Right.
And I think if Lincoln were to be here now at our Global Star Party, he would have been most interested in what you just said.
Well, thank you, David.
I believe that's true. Okay, gentlemen, we are going to turn to Bob Fugate. Bob's program tonight is the pale red dot. And we've all heard of the pale blue dot, Carl Sagan's famous, commentary on the the image of Earth from the Voyager spacecraft. But Bob, tell us more about the red pale dot.
Okay, let's see. I'm looking for my presentation, which I don't see at the moment. It's
Okay.
gone missing. Hang on just a second here.
We did learn that there are wandering black holes in our galaxy.
Okay, this is really, oh, here it is. I think here it is. Okay, let me share my screen, and I'm on a different computer tonight, and so things are a little
Unfamiliar.
Right?
By the way, thanks for coming on Global Star Party again.
Okay. Oh my gosh! Now I've got to do something else. Hang on. Oh dear, this is. Okay, I'm going to have to disconnect for just a second. I'll be right back.
Sure. So sometimes we have a little bit of a technical difficulty, but it will be okay here. So let me read some comments here, guys. Cesar Brollo says, in David's Facebook post about historical places, I fall like a flight of honey. They are fabulous. Norm Hughes says, I enjoy any presentation by David Eicher. They're always very, very well presented. It looks like Bob's back.
Okay, am I back?
You are back.
Okay, let me try again and see if I can. Find my briefing again.
We see your Zoom application.
Okay, so what happened to my presentation in the meantime?
If you stop sharing and then you go back in and just highlight you'll find your presentation, and then you click on that and then share. It's always brutal when you're on a different computer.
Okay, I think I found it.
Okay.
Sorry for this.
It's okay.
I'm usually much better prepared.
One time I had to cancel a whole global star party because of problems I was having. So.
Okay, so let's see if I can get this started.
Okay, that's perfect.
How's that?
Perfect.
Okay, sorry for all the confusion, everybody. So let's see. It's great that David mentioned M81 and M82 because my story starts in that region. This was a picture I took actually down in Magdalena, New Mexico at John Briggs' place. I was down there to actually observe an occultation of Mars by the moon. And that occurred in the early morning hours. And before that, this was in February of 2020, just before the pandemic started. So it was kind of my last trip to do any observing in Magdalena, and I haven't been able to get back since. But at any rate, I had a borrowed Takahashi Epsilon 180 ED, a great telescope, and I had my Nikon D850 attached. I did not have an astronomical camera at the time that I could use. So I took pictures of M81 and M82. I took 26 4-minute exposures. And when I processed them, I got this image. And as you know, this region is very famous for something called integrated flux nebula.
Wow.
which is the cloudy looking material you see in the background of the image. So this is dust and clouds basically illuminated by the total light from the galaxy, not from a particular star or a few stars. And so it's the integrated light from the galaxy that illuminates this dusty region and allows us to see it. It is quite
Wow.
faint, but it's also, quite popular to photograph. Now, just above M81 in the center of the image, and for some reason I don't have my cursor either. So let's zoom in a little bit on M81. And if we look just above it, and by the way, this is just a really gorgeous region. There's lots of galaxies. There's an irregular galaxy just next to M81 there. And they seem to be mostly everywhere. So I'm going to zoom in again. And then I'm going to zoom one more time. This is now at 800%. And right in the middle, right in the middle of the image, there's what I call a pale red dot. And so I got to looking at this image, in the week or so that followed, and I wondered what the limiting magnitude was. And so I tried to start looking up some of these stars in catalogs to figure out, how deep I had gotten in the image. For instance, the star at the top, the little binary star at the top there is about 14th magnitude. The one to the right of it is about 15th. So I wondered how faint these others were. And so I have this program called Sky Safari, and I tried to match. So this is an overlay on the image of a crop out of Sky Safari whose opacity has been reduced. So I can see through the catalog, the star map, into my image. And the bright spots are in the catalog, and you can see the images of the stars behind them and how they line up. And for some reason, that pale red dot was identified in a galactic catalog, PGC 5204082. And so in Sky Safari, when I looked for the information about that particular galaxy, I see this. It's 7.7 billion light years away.
Wow.
And it's traveling at 44% the speed of light.
Wow.
I just thought to myself, this is not possible. How can I be seeing a galaxy that's that far away with a 7-inch telescope, on a plot of land somewhere in New Mexico? So I discussed this with John Briggs, and he has a friend at the University of Chicago who is a principal at the Sloan Digital Sky Survey. And I noticed in the listing here that it has an SDSS designation. And so I got in touch with him. It's Professor Richard Cron at the University of Chicago. And he verified that, in fact, the object in my image was that galaxy, and that it has a magnitude of 20.84. It is very red-shifted galaxy whose spectrum has actually been measured at SDSS and observed by WISE and Spitzer Space Telescope.
Wow.
And he notes that the spectrum is redshifted with a value of Z equals 0.44. This is, measured with a spectrometer and unrelated to any cosmological model. It's just, a physical measurement of its redshift. So now I don't know anything about cosmology, but I got to looking into it, and this is kind of the exploration, in addition to exploring my image, I started getting into understanding a little bit about cosmology. And that was the awakening part for me. And basically what I learned was that, the cosmologists use these formulas that look simple, that the velocity is the Hubble constant times something called the distance now, and which is based on some proper time frame, like the time since the Big Bang, for instance. And the velocity is related to the redshift by that relatively simple formula, 1 plus z equals e to the v over c, where c is the speed of light. And so when we plug these numbers into these equations, we get a little bit different answer than what's listed in Sky Safari, but they're still just mind-boggling numbers. The velocity is 0.36 light speed, and the distance is 5.11 billion light years.
Still
So
very
if this
far away.
is right, and I really, encourage members of the Star Party to check this out and tell me where I'm making a big mistake here. With only a 7-inch telescope, I was able to detect photons, and I measured the signal, and it's a few tens of photons in that pale red dot over 104 minutes of integration. So they're not arriving every second, they're arriving, occasionally. And those photons left a galaxy that is, they left that galaxy nearly 1 billion years before the solar system and the sun even existed.
Wow.
So that was quite an awakening for me. Now,
Yes.
what I did was I got an image made by the 2.5 meter Sloan telescope, which is in southern New Mexico, that does the sky survey. I got it off of their server, and I scaled it and overlaid it on my image. And I made this little animated GIF that shows you the two images compared. And I put some marks on there to show you where my pale red dot is. So you can see which one is the Sloan image. It has a marker at the bottom called Science Server. And I think this is pretty remarkable. I mean, yeah, I think the Sloan image is deeper. It's, has better resolution probably because the seeing may be better there. But as I told you earlier, my 7-inch telescope probably doesn't have, or the 2.5 meter telescope doesn't really have any better resolution than my 7-inch telescope because of the atmosphere. But the big difference, of course, is the Sloan image exposure was only 54 seconds. My image was 104 minutes. And when I tried to compare that in terms of realism, I looked at the aperture size, the F numbers, the plate scales, the possible differences in seeing, the F numbers, all of that stuff. And in the wash, it turned out that in theory, the Sloan telescope should have been about 60 times more sensitive. So that would mean that the Sloan exposure of 54 seconds is roughly equivalent to my exposure of 54 minutes. My actual exposure was 104 minutes, double that. So, within any time you can get within a factor of 2 in this kind of work, I think you're doing pretty well.
Really
So anyway,
well.
that's I hope this shows up fairly well on the video, but this is kind of what I was doing. Now, this was in 2020. A year later, I got my own telescope, a 4-inch, it's the Takahashi FSQ 106. And I tried this same image from my backyard here in Albuquerque. And as I mentioned before, if you know the sky brightness, that kind of gives you a leg up on how much additional exposure you need if you're in a brighter sky. And so the sky difference between Magdalena and my backyard is about 2 magnitudes per square arc second. And if I, so 2.51 to the 2 power, or in this case, 2.2 power, gives 7.57 as a factor. So that means that if I expose 7.57 times longer in Albuquerque in the bright light pollution, I should get about the same signal to noise that I got in Magdalena. So I didn't get the 7.57, I only got 6.63 because the image on the right is from my backyard through the Takahashi, and it's 689 minutes of exposure. So it's over 11 hours. But I was able to see my pale red dot in that image. Probably not as high a signal to noise. And also, there was a lot more light pollution that I didn't get out of the picture. But you can see vestiges of the integrated flux nebula in both images, and they kind of correspond. So I also made a little animated GIF here that shows the 3 images, one after the other: Magdalena, Albuquerque, and SDS, just as a comparison. And then this year, in the late winter, I tried again, but I didn't have as much time. I only had 54 minutes. And here is my pale red dot from 2022. A lot more light pollution in this image just because I haven't gotten enough exposure. This is over a factor of 10 less than what I did in 2021. So, but it's interesting that maybe it's just noise, but it actually in this image looks like it has some shape other than what you would get from a star. And I also did a plate solve and look and identified magnitudes in this cropped part of the image, and it looks like comparing it with known stars in the image, it looks like it might be around 19.5 in magnitude. So, for 54 minutes in my backyard, having a limiting magnitude of 19.5 isn't too bad. So this is the instrument I used to take that last picture and the one in 2021. And so that's my story, and I'm sticking to it.
That is amazing. That is amazing. There we go. Here we go. Bob, that I love seeing stuff like that, because that is like, that's like totally breaking the boundaries of what, amateur astronomers are thought to be able to do, so it's, I think that, if you compare that against what professional astronomers have done, and you're going up against some of the best sky surveys in the world, it is spectacular to know that you can look that far back into time to detect that. And what else is really cool too is that in the astronomy community, that amateurs and professionals actually really do interact with each other quite a bit. And that is not something you see in a lot of other fields of science. And so I think it's a really fascinating aspect of our lifestyle.
Yeah, it's really true that what you can do with a small telescope, even in some light pollution, is quite awakening. And and so it's really fun, I think, to just, I mean, this was the first time I'd really done any kind of in-depth exploring of an image like that. And I'm sure that others have done this before, and this is maybe a so what, but it was quite a revelation to me to think that we're seeing photons coming from an object that left there before the sun existed.
Yeah.
I mean, it's
Everything that we know is created.
pretty mind-blowing for me.
I think for all of us. Thank you so much. Thanks, Bob. Fascinating presentation. It was great. So up next, it will be Professor Karim Jaffer. Karim could not be with us live today, so he, undaunted, he recorded his presentation and had me download it to show today. So we're going to start with that, but he has given presentations on a number of global star parties, and he's a fascinating guy, really involved in educational outreach in astronomy, not only through his teachings at John Abbott College, but through the Royal Astronomical Society and the Montreal Center. So without further ado, I will bring up his program, which I hope that you enjoy.
Hi, Scott. Hi, everyone. It's great to be part of Global Star Party 98, even if it's a recorded offering. I'm sorry I can't be with you live tonight, but I didn't want to miss out on this wonderful Global Star Party that's occurring on the summer solstice. I even dressed for the occasion with something a little bit more summery than my usual sweaters and long sleeve outfits. I thought with the topic of exploration and awakening, it's a great time to go back to some two-eyed seeing and look at the global view from history of the summer solstice, and specifically the idea of the way in which it allows us to see commonalities in different cultures. But before I do, I wanted to do a brief check-in on some of the topics that we've been talking about over the last couple of weeks when I do my intros to my segments here at the Global Star Parties. Yesterday, we had a live offering of Space Oddities Weekly. Now we have some wonderful weekly content. We have Lou Mayo giving us an exoplanet series, and Andy Briggs is talking about different types of neutron stars. We started out with pulsars, we went to magnetars, and I know Dr. Barth was talking magnetars yesterday as well. I've mentioned to you that this Saturday we have an amazing Helen Sawyer Hogg lecture, which is one of the keynotes for our RASC General Assembly that's happening this weekend. Natalie Willette, who's a local Montrealer, she's the communications coordinator or outreach scientist for the James Webb Space Telescope and the coordinator of the Institute for Research on Exoplanets, and she's going to be giving our annual keynote. If you're interested in the General Assembly overall, there are tickets still available. Please just visit rascga2022.ca for more information and to purchase tickets. And I also mentioned to you that Creation Station is open for any content from youth ages 5 to 17 who want to share a little bit of their imagination and the way in which they see space and astronomy and the cosmos. Their awakening to an understanding of their place in the cosmos is incredibly important in their education, and giving them a space to express their creativity. That's where STEAM education really starts to take hold. Speaking of youth, our Cosmic Generation, the astronomy organization for youth, by youth, supported by the RASC, by the Astronomical League, and of course by the Explore Alliance, they have their next workshop this Sunday. It's happening at 2 p.m. Pacific, 3 p.m. Mountain, 5 p.m. Eastern, 4 p.m. Central Time, whatever time zone you're in. But they're going to be talking about black holes, how they're made, what they're made of, and there will be an artistic element as well. If you're interested in signing up, you have to be a youth up to age 18 and go to bit.ly/CG June 2022. And we will put that address in the chat. And then, of course, any youth that want to present to the Cosmic Generation are welcome to email thecosmicgen@gmail.com with your ideas. Now, I want to talk two-eyed seeing. And so I find the best way to do this is to start off with a land and sky acknowledgement. And we talked last week about the fact that this is the full strawberry moon for most settlers, and a lot of the indigenous peoples refer to it as the strawberry moon because the strawberries are in full blossom. I'm going to talk about that in a few moments, but I want to thank Harold Locke for getting up early this morning and getting that picture there of the last quarter moon. Beautiful picture. I had nothing but clouds here, so I wasn't able to get the planet party or the moon. So thank you very much, Harold. And I mentioned that in Canada, it's National Indigenous History Month in June. Well, today is National Indigenous Peoples Day. And it's the 25th such day. And it really is a chance for us to reflect a little on the importance of acknowledging Indigenous culture, but also the wonderful things that the Indigenous people had set up already within this land that is an unclaimed land that we have now settled on as settlers coming from different parts of the world. So we do hope to move forward in a process of reconciliation and a respect for all of the different perspectives on the way in which, for us, the night sky matches our observations and our traditions. So I want to talk a little bit more about that, but I think with this being the summer solstice, it's important to recognize what the summer solstice means. So we know that the Earth has a tilt of about 23 degrees, and as it orbits around the sun, this is what causes the seasons. So our June 21st, 22nd, the summer solstice, and it really is, around the 21st, 22nd, depending on what part of the country you were, or what part of the world you were in, our northern hemisphere is tilted towards the sun. So right near the North Pole, the sun doesn't set at all. For the rest of the northern hemisphere, this is the longest day of the year. Winter solstice, on the other hand, for us, which is in December, that's when we have the shortest day of the year because it's the southern hemisphere that's tilted towards the sun. So if we look more closely at that summer solstice where we are right now, what we see is that the sun's rays are coming in directly towards that 23.5 latitude that we have, which we note as the Tropic of Cancer. And then in the wintertime is coming directly at the Tropic of Capricorn. So you can see there that above the Arctic Circle, there's no nighttime to be had. There's no night that comes during this day of summer solstice. Now, Eratosthenes, back in 240 BC, recognized that there was this town south of where he lived in Alexandria, where on the summer solstice, there was no shadow to be seen anywhere, and the sun shone directly down a very, very nice vertical well. Now, Syene, or Aswan as it's known, that lies directly on that tropic, the Tropic of Cancer. Now, at the time, what Eratosthenes knew was that in Alexandria, there was always a shadow. There was no day of the year where there was no shadow. But in Syene, there was this one day just on the summer solstice around June 21st, June 22nd, that you could actually see that there was no shadow. The sun was directly overhead at local noon. So what he realized is that if he took the distance between Alexandria and Syene, he could measure an angle of a shadow in Alexandria, and if he extended that to the curvature of the Earth, he could actually get an approximation for the circumference of the Earth. So the incoming sunlight was perpendicular to the surface at Syene, which is why there was no shadow. But in Alexandria, because the Earth had already started to curve, even though they're very, very close together, they're only a few hundred miles apart, that curvature would create a small amount of shadow. So he measured that shadow on the summer solstice, and he got a shadow of about 7 degrees. It was actually 7.7 degrees and 12 arc seconds, so 7 1/5 roughly. That works out to 1/50th of a circle, where a circle is 360 degrees. Now, the distance from Alexandria to Syene was measured in Greek units of 5,000 stadia. A stadia is around 155 meters. So that gives you about 800 kilometers difference between Alexandria and Syene. So when you convert that to the size of an entire circle, the circumference of the Earth, you get to within 1% of the current known value. You get to right around 40,000 kilometers. That's incredible. Now, at the time, there was an Italian unit also called stadia, which was different by a fair amount, so that if you use the Italian units, you would be off by 16%. And a lot of academics would argue that, oh, Eratosthenes wasn't really that close, but we know that he was Greek, so it's likely the Greek stadia that he was using. Now, my students, as many of you will remember, I've talked about this before, we work with the Eratosthenes experiment, not on the solstice because, well, we're not in school, but on the equinox, because on the vernal and autumnal equinox, the sun shines directly perpendicular at the equator, which means your latitude is the angle of the shadow that you measure. And so we participate in this global experiment, which is fantastic, and we share our data with schools from other countries, including Colombia, Brazil. We include, I believe there was one in Florida and a couple in northern Quebec that we shared with this past couple of years. So it's a fantastic way to participate in a citizen science experiment to really confirm the circumference of the Earth. Now, that's not the only thing that Egypt does at the summer solstice. If you go near the Sphinx and you look towards the Great Pyramids, you find that on the summer solstice, the sun sets directly between those two pyramids. And in fact, if you go to the Temple of Karnak, which is Amun-Ra's temple, the sun shines through the western gate and illuminates this inner sanctum only on that one day, which is known as the holiest of holies. We also know that other cultures identify the importance of the location of the sun throughout the year. So Chanquillo in Peru is one of these archaeoastronomical complexes where there's no people left to tell us what they observed. But if you go to one of these beautiful solar observatories and you look out towards the mountainsides, you see this range of teeth. And across those teeth, what you find is that from one end to the other is the entire expanse of the rising point of the sun throughout the year. When for Peru, since it's in the southern hemisphere, December is your longest day and June is your shortest day, and the equinox happens when you have 12 hours of daylight and 12 hours of sunlight. Now, this idea that the sun rises at different locations and also to different altitudes in the sky is something that you can take a picture of yourself. And we did this at John Abbott, and I've shared this picture with the audience before. This is a solargraphy picture from the roof of my science building, seeing the path of the sun from winter solstice 2020 to summer solstice 2021. And yeah, that happened when we had very few people on campus because that's when COVID began. Recently, the Mi'kmaq parks actually set up this sky pillar, which is aligned directly north-south. So at local noon, you have the north-south meridian. The length of the shadow tells you what time of year you're in, because you'll have the shortest shadow in the summertime when the sun is the highest, and the longest shadow in the wintertime when the sun is the lowest. And you can see behind Dave here, behind these two pillars, you have separated stones in steps, just like those steps that we saw in Chanquillo. In Chaco Canyon in New Mexico, we have an observation section where Chaco Canyon, I mean, it's known for having a petroglyph of the observation of the Crab Nebula, of Halley's Comet passing through. But we also see this beautiful sun dagger that occurs directly through this incredible spiral right at summer solstice. And so at summer solstice, you get this dagger that comes right through the middle of this spiral. Now, this sun dagger that comes through at summer solstice in one position comes through at a different position during the equinoxes and has a second dagger that occurs in what's now been identified as a smaller spiral. And in winter solstice, those two daggers are actually separated around this larger spiral. Now, this is an actual natural phenomena, these two gaps. But when identifying where the sunlight fell, the people of Chaco Canyon, the Anasazi, the enemy people as they were called by the other tribes there, they actually went and inscribed these spirals that show not just where the sun is, but also where the full moon was over the span of the 18-year Ceres cycle. Here in Montreal, we have what's called Montreal North, which actually doesn't point north. It points at 303 degrees azimuthal angle. And so that is exactly where on summer solstice sunset happens. And my friend Trevor in Plateau Astro put together this beautiful video talking about this, as well as a similar type of orientation that doesn't happen at the summer solstice, but happens in May in Manhattan, called Manhattanhenge. And it's named after Stonehenge, which is where this morning there were likely a ton of people getting up early to see the sun rise through the stones there in Applebury. We also have in Wyoming the Bighorn Medicine Wheel. The Bighorn Medicine Wheel is one of those indigenous structures that really does align with the sun's positions as well as the positions of certain stars throughout the year. Now, the age of this medicine wheel is one thing that I've not been able to find any clear-cut answer, but it's not the only one. There are actually 6 of these different types of medicine wheels all across the Rockies coming up into Canada. And in fact, in Majorville in Alberta, the medicine wheel there was aged to 4,500 years old. So this actually predates Stonehenge, this observation of where the sun is at different times. Now, the celebration of this summer festival by most of the indigenous peoples is a multi-day celebration. It's a celebration of life and death, a cycle of renewal and continuity. And the sun dance by the Ojibwe people is one of the ways in which they cherish and they mark this. And in fact, it's based on the idea that Mother Earth offers her first fruits at the start of summer. So remember the strawberry moon? That's the first fruits that the indigenous peoples would start to harvest, while the other fruits were still too young. Here in Ottawa, the capital of Canada, we have this weekend an incredible festival held by the Algonquin tribes, and it's a summer solstice festival. It's a multi-day festival with powwows, with workshops, with talks, with story time. It's an incredible event. And if anybody is in Ottawa watching, please go and participate, learn a little bit about the indigenous cultures there. I'm going to leave you with this image. This is an image of an early morning set of prayers, dances, and songs on Hawaiian land with Mauna Kea out in the distance, and it's identifying this connection to nature on the summer solstice. And I'm using this to kind of connect our explorations and awakening, because we do a lot of our cosmic explorations from the top of Mauna Kea. And we have to do so in a respectful fashion, because that's also the seat of the gods for a lot of the stories of the Hawaiian peoples. So when they do these wonderful gatherings to celebrate the summer solstice, we should respect their observations and their connection to nature, and make sure that when we do our explorations and our second eye seeing with the modern world's knowledge, that we are not forgetting to keep both eyes open. That's it from here in the Montreal Center. Thank you, Scott. And now back to you.
And I think I'm muted. Thank you, Karim, for making that presentation. Hopefully you were back and able to watch that from wherever you are. We're running a little bit ahead, so if you're watching the schedule, you'll see that. But Cesar Brollo from Buenos Aires, Argentina, is with us now. And Cesar, how are you?
Fine, Scott. How are you? Hello to everyone. Can you hear me good?
Yep. Yeah. Oh, yeah. Loud and clear.
Thank you.
Loud and clear. Now, what did you think of Bob Fugate's image of that red pale dot?
I was totally astonishing, because every time it's I write it because I started watching, like being part of the audience in YouTube, and I enjoyed the Bob Fugate presentation. The images are incredible. Really well. The last week about adaptative optics. And
oh yeah, I know that's especially of interest to you. Yes,
it's impression for me is that it's one of the developers, and as an optician, I really totally amazed, because it's great. I think that is a part of the history, because exists the image before and after about adaptive optics.
Oh yes,
this is something real that because you not ever have your scope in the space like the Hubble or today the Webb telescope. if you have a huge mirror, but you don't have this kind of techniques, you lost so quantity of information. And I remember that the first time that I wrote about the it's like a fingers moving a piece of glass, as for me was totally, come on, it's possible. No, it's really, and listen to Bob, that Bob will say, come on, it's the man that work and develop this technique.
I think that technology probably is as important as the invention of the telescope itself. I really do. It was a giant shift in what we were able to detect. And again, the spirit and the techniques and the efforts and everything, as it drills down to the realm of amateur astronomy, as shown by Bob, and occasionally I'm shown this by other amateur astronomers who do these super long, deep exposures. They're pulling back the veil of mystery, and we're able to see the universe in ways that no one would expect amateur astronomers to present. So
yes, it's absolutely fantastic, the time that we are living, because we have a conjunction of works between amateurs and professionals that never we've seen in the past, because the possibilities of the instrumental that the people have in their observatory homes are totally different. Every time are more sensitive, more sometimes bigger diameters. This is why maybe you have optics volume and say, okay, we started from the 70 centimeters optics, but
Right.
I think that it's maybe a real future where their big telescope came more affordable to the people, because technology, for example, we never expect that today the kind of telescope that are affordable to the amateur astronomers.
Very true.
In 30 years that I work in selling telescopes, are totally different. The possibilities for amateurs, especially where cameras and everything about the stuff, gears, this changed totally the game. Something that was happy for me today, because do you remember the last week I was scaling in the end of my presentation. I made something easy, that is take with different focal lengths this Eta Carina nebula. That is typical. It's a huge nebula, very easy to watch in the south hemisphere. Of course, that where I live in the middle of the city, where I made astronomy from my balcony or from the rooftop of my building. I have less possibilities of take pictures, but this nebula is bright. And something that today was happy, made me happy, was that when I post the picture of I took last Saturday with RC telescope, because I had with this when only the picture of with my camera in different objectives, but I expected to take a picture of Eta Carina with a telescope of 8 inches with a f9 focal razor. Of course, that is a picture that is not so good, but let me share the screen. If I have, I don't know if I can see. Okay.
There you go.
Okay, okay. This is something that I'll show you later because it's very interesting, and this is the thing that I had in my Facebook page. This is I explained a little minutes ago. Ahead, sorry. Here, okay. Well, okay, you can see the presentation now. Okay. Well,
Yes.
Sorry that. Yes, but I need to go to the first.
Okay.
Yes, it's. Sorry.
You know why
Yeah,
it's this
yeah,
way? Some of these problems. It's because it's the.
No, yes, I have some.
It's because winter is today, so that's why.
Yes. Yeah.
It's made a shift.
Okay, now it's okay.
And in summer.
Yes, I took something. Yes, it's only 5 slides, no more, but I put everyone together. Okay.
Okay.
Scaling like the first was the last thing of the last week. Of course, I have the first picture. It's with an angular objective where you have here. Eta Carina Nebula. Here you have the Southern Cross, the called SOC, Alpha Centauri, Beta Centauri. And here, of course, that in the city, you can see only the Southern Cross, only Alpha and Beta Centauri stars, and no more than this. And of course, that this picture have a process as it's very different to the reality, but it's a real picture. But it's only for scale, only for talk about the scale of the things in the city, mixed with the buildings. Here I took Eta Carina Nebula and this open cluster, very big, near to Eta Carina. I put a mask only in the side of the building. This is from my balcony.
Mm-hmm.
Sometimes it's really fun. Make the scale of a window at no more than 20 meters with a teleobjective, normal teleobjective of 200 millimeters. And the nebula to make the idea of size, of angular size. But here it played solve for the area. It's not the name of my neighbor that I said last week. And here. With a 30 millimeters teleobjective. And in this area, here you have the Eta Carina star that is coming to be bright every year, is writing more. It's a star that make an eruption, a very particular eruption in 1853, I think, in the 19th century.
Mm-hmm.
And here is the last picture of in the rooftop with the Ritchie Grettir telescope of inches,
Mhm.
and here you have the star Eta Carina that actually is near to magnitude 4. I remember that I knew this star one magnitude around 5 or 6 maybe, but 5 I'm sure that I remember that I knew. I took pictures on and I see this star in magnitude 5. Actually is near to 4. It's going to explode again. It's something that is, of course, that not now. All is in terms of astronomy times. Maybe, I don't know. When the people tell me and I say, okay, ask to the astronomer, not to me, but when I ask to my friend astronomers, professional astronomers, I say, come on, or people tell me to me when it can explode. Of course, that I don't know. Now, 100 years, 1,000 years is nothing in astronomy terms. But it's interesting that this star, it's only at 7,000 years, light years, sorry. And it will be a little, for example, for an explosion of this type of nova in our own neighborhood in the galaxy, it will be just a little interesting for radiation. Of course, that I started to make the same that all people when is going to make when you took a picture. You in amateur astronomy is very interesting. Not only watch the picture, if not comparing with all pictures, if all is okay, or if the things are, for example, in this case of Eta Carina, we know that is a star that is going to bright every time more, and take the time to read about the star. It's really great. And something that I have, let me see if I can show you another picture more that I have from 2011. If I have another picture, maybe. Yes, look this. I found this picture from 20. If you, of course, that is different, the picture, but you can see this picture is from Rafael Mendoza, San Rafael Mendoza, where you have a Bortle 2 or 3, maybe. In my home is 9.5. But if you compare between the stars, the bright of the stars, of course that you understand me that is different, the mask of the stars, the processing, the telescope, both telescopes are of 8 inches, but come on, the bright, when you see this, the comparing the Eta Carina star with their neighbor stars are not so different. Like if you see, let me return here. Sorry that I couldn't put together the pictures. I don't have time, but you can see it's very easy to understand with the same. The camera is the same. The camera is exactly the same. The focal it's 9 here, the focal ratio. here is 9, and another picture is 6.3 with a focal reducer. But if you compare, in another picture, do you have a star more similar with the neighbor stars?
Mm.
Now do you have a real difference in only 12 years? Something that make me happy is that a professional astronomer today, when I posted this picture in Facebook, he gave me the link of his own work. His name is Eduardo Fernández Lajus. He worked in the Complejo Astronómico El Leoncito and the University of La Plata. In the same work is the Astronomical Variable Star Observers, of course. And look the change of brights. For example, this is totally from 2003 to now. Here I took the picture where I had magnitude 5.20, and now you are going to 4.6. This is in blue. Yes, it's very interesting, the change of the bright in this, and the behavior of this star is really interesting here in the South Hemisphere, where we are going to have, I don't know when, a massive nova, or I don't know if a supernova, but I think that sure that a type of nova. Well, here are the different components of the magnitude. And if you, let me show you. If, here, let me show you the historical, here, the historical. Look that, in 8050 is the historical explosion, and like a nova. Is of course the time where you have astronomical observation, because in this year is we can talk about the something modern science, and here is very interesting. How do you have the brightest one there was this star was one of the brightest star in the sky in the 8050, and actually, of course, that is going every time to go more brighter, and brighter. Sorry, not more brighter. Well, this is something that when we talk pictures, and especially people that start with telescope, they can pay attention, and something that is really, how do you say, really is something that is information easy to understand. It's not a paper very complicated, but you have a lot of information, for example, of this star, and you can enjoy something that is very interesting to know in the sky from a city, from your small telescope. Of course, that I took the picture with a little bigger telescope, but not a professional telescope, a telescope normal with a reflex camera. And of course that I don't make estimation of photometry, but something very simple, like see pictures of amateur pictures, where you can compare something like it with the two pictures that I have. You can say, yes, it's really brighter. It really is something that you can learn only with a picture that you take for your backyard, your rooftop, or your balcony.
Okay.
I not intended to make a scientific work, but of course that Eduardo Fernandez Lajos, that is astronomer, I invited to talk about the star. And of course that in next weeks, next global star party, he told me, yes, I can go. Okay, perfect. Because if I start to talk about the stars, because no, you need to, I need to explain something about, astrophysics that is not my area, but only that something that I can say is that you can compare your pictures and you can find a lot of information of something that can you how do you say, something that well, maybe the word is amazing. You can be amazed and you can be open to feel amazed by astronomy.
Absolutely. Well put, Cesar. That's great. Thank you. Thank you for your presentation today. We are, as I mentioned, we're running a little bit ahead, but it's okay. We are going to take a 10-minute break, and then we're going to come right back with Deepti Gautam from Nepal, and we're glad to have her back on. It's been a little while since she's been with us. So anyways, hope you're enjoying the 98th Global Star Party, and we'll be right back.
Hello, everyone. It's Bob Fugate from Albuquerque, New Mexico. Congratulations to the Global Star Party on achieving 100 exciting episodes. Please keep up the great work. Thank you.
Howdy, Scott, Explorer Alliance, Astronomical League, and esteemed Global Star Party friends. This is Cameron from Camp Astronomy, wishing you all a hearty congratulations on our 100th Global Star Party. Keep looking up and enjoy the journey. Cheers.
Hey folks, Sean here from Visible Dark on YouTube and visibledark.ca on the web. Just want to send a big congratulations to Scott and Explore Scientific on the 100th episode of the Global Star Party. Fantastic stuff. Keep up the great work. Here's to 100 more.
This is Karim, Jaffer, Explorer Alliance Ambassador and RASC Montreal Center Public Events Coordinator. I'm coming to you under a strawberry full moon, and I'm looking forward to a couple of weeks of waning moon and dark skies. I'm looking even more forward to the 100th Global Star Party. It's coming soon to a screen near you.
Well, we're back. I hope that you had enough time to stretch your legs and get a drink and get a sandwich. We are truly, this is a global star party. We've got a global audience here. We just went down to Buenos Aires, Argentina, and now we're going to Nepal to meet up with Deepti Gautam. Deepti, thank you for coming on to Global Star Party once again.
Hello, Scott. Hello, everyone.
It's great to see you. It's great to see you. I've been following you on Facebook, and I know that you've been very busy at school. So what has been going on in your life lately?
Just now, I have completed my examination of high school, and we have a long vacations for the preparation of college application and university application. And so, as I already mentioned, that I am applying for the as I'm international students, and I have to apply for the USA and for my further study. So my college application is going on, and I'm writing the essays and others preparation, SAT examinations. And
Wow.
further that, I was just now a few weeks ago, I conducted one programs in my own school. To the junior, I took the telescope and a small session with them where I mentioned about the opportunities of astronomy, not only in Nepal, but entire world. And the one question was raised by the student that, sis, did like you are coming here to give us knowledge about the astronomy, and he asked me that, even in America and other developed country, people goes to go with the peoples and go with the public and share about astronomy. And I said, yes, of course, because astronomy is all about, not only about the rocket launching and all about the space exploration, but it's about the giving the knowledge and giving the awareness about the astronomy, because astronomy is a vast subject. And as we know, today's our theme is exploration awakening, and there are more things to explore till now. There's so many explorations, and I want to connect today's with the themes like exploration is an investigations or travel experience. An example of the exploration on a deep sea is a diving journey to find a new sea life, right? And
Yes.
Something new and something that begin addition enlightening and awakening experience are moment in which our awareness expand, and it's somehow the result of explorations leads today's era. For example, exploration of small things are leading a vast discovery. And while seeing this backstory of all the discoveries, we can see the scientists are engaging in the small things, but lead the vast and very large discoveries. So, and for examples, the modern era is also the result of the exploration and awakening. Without
Yes.
exploration and awakening, the life doesn't go ahead. And for example, I want to connect with that. And I have some knowledge, like currently NASA human explorations planning its capability, drive on following a flexible path of missions with increasing the capability into the inner solar systems. It includes the multiple destinations where a human interface with the and explore the surface of Moon, Mars, and asteroid. And as we know, more we explore, more we get information. And this day, I haven't made presentation. Sorry for that, because I was busy till late night for my programs, other programs, which we concluded in the one of the University of Nepal, that is Fulchok University, which is the engineering college. And we conducted the solar observations plus orientation programs, and plus we give them a knowledge about the stellarium and other sky maps to the students.
Mhm.
And today I'm here with a small poem, because I take a large
Okay.
gap from the global
I
star
love your
party.
poems. Yeah.
Okay. Strange universe. They do not know why people born and die. Even a child doesn't know why he does cry. Why people walk and move here and there. They do not know even why do go to fear. Care they take of each other's, do not why. Thinking more on this, many break inside. Sky fills with star, cloud filled with the raindrops. Land produce freely for food more crops. Science searches for many galaxies and planets. Some sleep in a cold for pleasures in covered blankets. Some get food, some do not at all and fall down. One becomes labor, another wears your crown. Saul does actions but doesn't able to know. Snow falls on hill like attitude. Saul does so. Saul again goes away from the body, enters another's. He travels in between birth and death furthers. Stars and planets are hung in space in dark matters, never fall down, even move in a track. It's look better. Force of gravitation controls working of us on the earth. God knows all secrets of strange universe and birth. Thank you.
Wow. I love that. I love that. Deepti, that's great. So, Deepti, I want you to know, if before you were talking also, I mean, months ago, maybe a year ago, you were talking about maybe studying in the United States. And if you ever need a reference,
Yes.
I will be happy to give you a reference, no problem. You just approach me, tell me when, and I will write a glowing letter of recommendation for you. You know, I think that you are,
Thank you so
an
much.
inspiration and a powerhouse in astronomy education, and you've done so well here. So thank you so much. Thank you.
Yeah, I'm just starting my college applications and writing essays. Further, I'll be taking a step back and some college research, which college are better for my further studies, and for some study and major course and minor course. I'm doing research about that. And furthermore, I wrote an email just before 2 days to you about some help and all. And so I'm hoping that, and
Okay.
I think I will be connecting with you after this global star party.
Please do.
Directly in this.
Please do.
Okay, yeah.
I'm sure there's many
Okay.
people here on the presenters on Global Star Party that would also pitch in and help.
Okay.
So thank you very much, Deepti. That's
Okay.
great.
Thank you.
Take care. Bye-bye.
Take care, you
Okay.
too.
That's great. Love it. Love to see that Deepti was joining in on our 98th Global Star Party. Hopefully we can get her back for the 100th. I did mention that we are next week, I'm heading out to California. There's this very special event that's happening at Mount Wilson and at Caltech. George Ellery Hale, who built the Yerkes refractor, the Mount Wilson 60-inch telescope, the Mount Wilson 100-inch, and then the Palomar 200-inch telescope. He built in succession 4 of the world's largest telescopes. His extended family, of course, George Ellery Hale is long since gone, but his grandson has put together a family reunion. It may be one of the only family reunions that the Hale family's ever had, at least in recent memory. And so they are having a special celebration of this gathering at Caltech, at the Athenaeum, and also at Mount Wilson Observatory. So from what I understand, there's going to be some amazing speakers there. I think Wendy Friedman will be there giving a talk, as well as other people from the Carnegie Institute. So I'm very, very excited about it. I've been invited to live simulcast some of these talks, and we hope to bring you some of the experience of this historic gathering, which will happen next weekend. So I'm heading out there on Tuesday, so I will miss a week of Global Star Party. We'll come back with the 99th Global Star Party on July 12th, and then the milestone 100th Global Star Party on July 19th. So there's a lot of people who want to join in on that. And, if I have to extend the schedule or whatever of Global Star Party number 100, then we'll do that. We've done it before. So I'm looking forward to it. Well, up next is Daniel Higgins from Astro World TV. Daniel, how are you?
How's it going, Scott? How's it
Good.
going, everybody? Am I too
Good.
loud? I think I'm
Yeah.
too loud.
Yeah. No, you're good.
Oh, okay.
Yeah.
I'm blasting over here in the room.
You're blasting.
I'll just turn it down. I can't hear myself in my can, so I don't know. I don't know what's going on. I'm just really shocked right now because it said 8:25 and it's 8:05.
It's 8:05. Yeah. So we're running ahead here. So that's partially my fault as I was juggling the schedule. I didn't do the sequencing exactly right. So, but thank you for coming on and hanging out with us. Maybe you can catch us up a little bit of what's been going on with Astro World TV.
Yeah. So first of all, let me say to Deepti, I just jumped in like literally as you were doing your presentation, and I got to be honest with you, it's people like yourself and the younger generation like yourself that that makes me want to do what I do. And it's you're the next generation of what we all do. Whatever position or field, whatever you decide to do in, just do it, enjoy it, love it, and you're gonna be great. So awesome presentation. I can't say I'm like glowing right now. I got a big smile. Yeah. But it's really great to see. No, awesome job, man. Very nice. But
thank you so much.
No problem. Thank you. But what I do, and I many people here have seen me on GSP or other places. I do a bi-weekly astrophotography, I guess, kind of a chat twice a week. So I do with me and a number of people. I have about 9 people that come in and out of the chat, plus a lot of special guests that we have. Scott Roberts has been one of them. We've also had 2 other people from GSP come on. Adrian Bradley just last week came on and gave us a nice presentation on the Nightscapes and his techniques. And then a couple of weeks before that, we had Maxi Falieres came on as well. So I mean, we've had a bunch of people come on. This Wednesday coming up, we have actually it's tomorrow. So tomorrow we have for his 3rd return to Astro World TV, we have Astro Doc, Ron Breacher from Masters of Pix Insight coming on. He's going to be showing us some of his techniques, and it's really geared toward astrophotography. But we really kind of talk about pretty much everything. A lot of people make fun of us because Scott will tell you we go off the rails and we'll all just talk about whatever.
No, that's good. It's all good. Yeah, you guys are fun.
And we like to keep it relaxed. We like to keep it fun, but we like to keep it informative. And it's unscripted and it's nice to have. So we got also coming up, we have Russell Croman coming up on July 8th. And he's going to be coming on showing us all of his new scripts for Pix Insight, which is a software program that's turning out to be pretty much the standard for astrophotography pre and post processing. And Russell writes some really good scripts that takes the stars out of pictures called Star Exterminator, and another one for PixInsight called Noise Exterminator, which, if you know anything about post-processing, sometimes noise requires making masks and protecting things and all this kind to make it easy to understand. His AI, his intelligence that he used doesn't require mask for anything. For a Star Exterminator or Noise Exterminator, it doesn't require anything, and it really brings out even some of the detail. It's really, really going to be cool to see. And we also have coming up to be scheduled David Gibson from Photonic Cleaning Solutions. So he's got a nice kind of thing it's like a gel to clean your optics. It's pretty cool. So I'm interested to see that. But for right now, that's what we got going on. I was just on Masters of PixInsight as well. But we've got a lot of stuff going on over at Astro. Come see us, hang out with us Wednesdays and Friday nights. Wednesdays are 9 p.m. Eastern. Fridays are 8 p.m. Eastern, and all of the other stuff. Plus, if I could show my screen real quick.
Please do.
Let's see, screen 2. And let me get it's gonna look. You're gonna see my desktop for a second, but I'll get it off there for you.
What is that image behind you?
This is my image of the Heart Nebula.
Okay.
I took.
Well, we all know you have a big heart, so.
Yeah, well, I appreciate that. Thanks. Well, this is actually a present for my wife. And it was supposed to be done in February, and because of the nasty weather that we've had in New York, it was really like I don't know, like Memorial Day after I got done processing everything. But it was about 26 hours worth of data on that from New York. So, do you see the web page?
Yeah,
okay.
We see it.
All right, so this is our webpage, and you can come visit us at astroworldweb.com. Not a great name, but that's when it was available. Towards the bottom, it will show you our upcoming special guests. So we got coming up, we got Ron Breacher, like I said, who's a PixInsight ambassador, followed by Kurt Lanes, who is a DIYer who made up his roll-off roof, and he's going to show us how he went about doing that. And then we got Russell Croman coming on July 8th. So definitely come check us out if any of that interests you. And of course, last week we had Adrian Bradley. I just didn't take it down yet. We also do Pictures of the Week. And we do Pictures of the Week contests, and it's all done by submissions of the membership. We have about 1,200 subscribers on YouTube. On the live shows, we have anywhere from 30 to 50 people. And on the Discord server, we have almost 70 people on the Discord server right now. So it's becoming a larger community. And every week we have a picture of the week followed by a picture of the month. All the pictures of the month are featured in the upcoming Astroworld calendar. So we'll have a calendar given to, that can be purchased through the members. And it's a lot of fun putting together. Plus, we also have tons of giveaways. We have a bunch of great sponsors, and this is just to become a member. You just come on in and you can sign up for these. We got Woodland Hills, IP for AP, Masters of PixInsight, Prima Luce, Camera Concepts, Optolong, and Charles Bracken just recently gave us 3 copies of his books signed that are going to be given away as well. So all you got to do is enter anyone you want, and it costs you nothing. So if you want it to cost you something, you can also join us on your Patreon account. So, but all these people have been very gracious with that. So that's pretty much all I got for that. That's what's coming up. So I don't want to throw off the early schedule. So right. But that's all I got. But thank you for coming on, and come join us on Wednesdays and Fridays.
Absolutely. That's great. Thanks so much, Daniel. we are, I really enjoy the whole crew that you have, and you guys do a great job. And I think that you make the learning curve of astrophotography seem a lot straighter than what a lot of people might otherwise experience. So
Yeah,
great job.
It could definitely, there's a lot of information on the lovely, YouTube could be a wonderful thing.
Yeah.
It could be a great thing, but it could also be very detrimental to your mental health. So you just got to be careful on what and who you listen to. I'll be the first one to admit, you don't want to listen to me all the time. You don't. But you know what? I have a bunch of people on the show that are smarter than me that are on the show. And
that's definitely my situation too. Everybody's smarter than me.
So it looks like we're going to need a bigger boat, Scott, because but you know what? It's not that the other people are smarter than me, but it is that we all have varying interests as far as astrophotography and difference of equipment. So I am an Eagle guy. I use Eagle. I'm a Prima Luce guy. I love my Eagle. We got two people that are ASI air users. We have one that's a William Optics user. We got two people that are Explore Scientifics users. We got, and we got all these different types of places that we can pull from.
It's cool though.
That if we don't have the answer, we'll just call Scott and he'll give us the answer. So,
I'll give you an answer, all right.
It may not be the one I want, but I'll get one.
It may not be the right answer, but I will give you one. So, anyways,
hey, thank you so much for having me on. I appreciate it.
Thank you so much.
And I'm looking forward to the 100th, and congratulations on everybody and all the presenters here.
Thanks a lot.
That have been doing it for 100 shows. Great job.
Thank you so much, dude. Take care.
You got it. Absolutely.
All right. Okay. So up next, we have Dustin Gibson from OPT, but Dustin also he's done so much more beyond Oceanside Photo and Telescope. He is an incredible astrophotographer in his own right. He is on a mission to introduce people to the sky through astrophotography, through these amazing experiences that really you can only have when you're with the telescope and really making these really cool long exposures. I think that Dustin has done some things that few other people in our industry have ever done. And so he's going to explain a little bit about it. I've asked him to share some of his images, but OPT is near and dear to me because that's kind of where I got my start. I started selling telescopes at a little store, a little camera shop called Oceanside Photographic Center. During the Halley's Comet era, we were selling lots of telescopes by that time and decided to change the name from OPC, Oceanside Photographic Center, to OPT, Oceanside Photo and Telescope. So that's kind of my story. But Dustin, thanks so much for coming on.
Scott, it's good to see you, man.
Good to see you too.
It's always good to see you. 98 episodes.
98. That's right.
I remember when you called me. I was doing the Twitch streaming every night, and you were like, I'm gonna do this thing, and I was like, Scott, it's a lot, man. It's a lot. And here you are, 98 episodes later. It's crazy, man. It's awesome though. Like every time I come in here, I get so inspired by the people that are talking to just keep charging forward. I mean, we have the best community on earth, man. I absolutely love it. But thanks for having me back on for what has to be the...
Yeah, I love your shirt. That's cool. You got your NASA hat on as well. So you must have just got back from maybe talking about the observatory that you're installing.
Yeah. I have city council stuff going on, but I'm not very good with those with those things, but they're a necessary part of it, working with government on making a lot of these things happen. But it's the mission, man. We got to get in front of as many people as we possibly can and show them why it is we've all gotten absolutely obsessed with it, right? And why it's such a huge perspective shift. So I think it's great, man. And there's a lot of positive momentum in helping more people access the night sky. And that's the mission. That's what I live for. And, that's what OPT does all day, every day. So,
Right.
but
I
it's,
spent,
it's good times.
the audience doesn't know this, but I spent a few days with you in your community, and I watched Dustin in action, inspiring this community that to get them full on up to their necks involved in a public observatory program. And so I know that Dustin and OPT and I'm sure there's other people involved in this as well, but they're installing a 24-inch telescope in that park. And so people in that area that have never had access to that kind of equipment before are going to be really enjoying that. And I think it will really open up some minds and propel the educational aspects in that community, because all this stuff improves scientific literacy. And so it's a great thing you're doing. So
thank you.
I'll let you take it from here.
As an industry as a whole, and just as a hobby, we don't rely on punchlines and slogans the way so many industries do, because everything we're doing, it carries true substance and things that go back to the earliest human development. It's like, this is something that's innate in our being. We are explorers, and this is something we want to do. And so getting it in front of people is the mission. And this one is for a very small town in Alabama. I doubt there's ever been a telescope here, honestly, but they're getting 6 telescopes. The largest is a 40-inch, so a 1 meter.
Oh, okay.
Yeah,
Wow.
it's a 1 meter, 2 24-inch, and then some refractors, including the one that you were nice enough to donate. This is what I love about you, Scott. Like, every time I have these crazy ideas, I call you. You're always the first one that's like, I'm in. Let's do it.
Right.
I love that. So
Hey,
thank
I do
you.
my best. So
Yeah,
I do my best.
yeah. Thank you, man. It's really good. But I know that you get this in front of kids, you get this in front of adults, and it's life-changing for people. So, it's just, it feels like a very important mission.
Right. Yeah.
But,
So but your passion also about astrophotography yourself, you have opened up, I think, a couple of different websites to kind of show some of the work that you've been doing. How would you characterize your approach to astrophotography?
Like a child is getting carried away with finger paints.
Okay.
Like, everything is ultra saturated and super colorful. It's definitely not a realist approach, but I love the color of it, and I like the artistic expression. Kat Machin is one of my best friends, the painter, and I just like pushing the limits on what you can bring out in the images. So it's certainly not something that's going to get APODs and those sort of things, but it's just something that gets people excited and gets more people talking about it. But I can share a few here.
Please do.
Is sharing on?
Always on. Yes.
Okay, perfect. Sorry, I never use Zoom anymore. Let me see if I can get this going.
No.
Is that there?
Yeah, it looks like you're a pro here. Yep.
All right. So yeah, this is one of my images. This is the Rosette Nebula from
Beautiful.
Landers, California. I shot this with a 17-inch plane wave that I have out there. I have 3 observatories in the desert out in Landers, and most of them anymore are not, I don't use them myself as much. I make them openly available to other people. So a lot of times they're being used, by other people. So I'm not getting images. But when I do, this is the type of thing I shoot. And this is one of my favorite images. I love the Rosette. It's my favorite target in the night sky. And this is obviously a narrow band. So hydrogen, sulfur, and oxygen 3. But, I just leave the colors in instead of removing the magenta in the stars. When you combine them with the Hubble palette, just leave it in, leave the color, push it, see what you can pull out of it. But this is the type of thing that I typically do. You can go through a few more here. This is the Horsehead.
Wow.
I almost always, yeah, thanks. I almost always pull the green out of the image because it's just so exaggerated. When you do the Hubble palette, hydrogen, which is the most abundant element in the universe, number 1 on the periodic table, is overwhelming in these images all the time. And so when you combine the Hubble palette, hydrogen is green, and you see a lot of green in the images typically. And so there are many ways to balance it. I almost always pull it out with something called SCNR noise reduction. But instead, on some of these, I just leave it. And really, if anything, I amplify it and say, look, like, let's look at this density of hydrogen and how much it blends across the image and where you actually find it. And I think it's really interesting. It's clearly not a realistic representation of the colors, but I think it tells us something else, you know, and I think it's pretty special when you can see this stuff and what's actually represented there.
Mm-hmm. You know, the question of color in astrophotography, with some people, they tend to think of the in more purist type of ideals, but you know what? Light is all colors, and so
right.
And so what you assign to an image, if it can bring out a certain detail, then that's great, you know. So but there's, we look at solar imaging, and Gary Palmer is a guy that comes on to Global Star Party and talks about assigning color to the sun, and he said you could assign purple, you could assign pink, any color, because it's all colors. And but there's an aesthetic that some people really ascribe to. But I see what you're doing is exciting, and it makes you stand up and take notice for sure. And I think it's great.
Yeah, well, thank you. And I get a few of the messages every now and then from the people that are like, you're not doing it right. You're not giving us the right colors. And that's the exact same thing. Look, I mean, that's what photography is. I'm not cataloging these for you. If you want that, there's plenty of that out there. You can go find a catalog and find the color. This is, in photography in general, is taking an everyday, or at least what is an everyday experience for you and your lifestyle, and creating artistic expression from it. That's what this should be. And people should celebrate, people doing things differently, trying to push the boundaries. And, I'm seeing kids now that are making every image I take look terrible. And I think that should be the goal. We should be trying to push people forward and challenge each other to do better and better work. But yeah, here's another one. This is another one of my favorites. I know it's probably the most photographed target in the night sky, but this is M42, the Orion Nebula. And
it looks like open heart surgery. It's amazing.
That one has about 40 hours of integration time in it. A lot of time into it. But it's just, there's so much detail that every time I thought I was done, I just kept looking at it. I'm like, we can pull more out of this. Let's do a little more time and see what we can get. But yeah, there's a lot there. And
the range, it's really great.
Yeah, it turned out well. I'm pretty happy with it. And I was having some trouble processing the core. It's so hard because it takes such incredible dynamic range to get that. So I had to it's a short exposure on the core, long exposure for everything else. And then Kat Machin helped me blend the two, but it's a lot of work that goes into some of those. Whereas this one was almost no work at all. This is RAW. And this was just literally a 4-inch refractor with a Fujifilm camera strapped on the back, and 2-minute exposures, out in the middle of the desert.
Wow.
There's a lot of color out there. And this one actually is true color, because it was shot with a color camera off the shelf, no cooler, no anything. Just pointed up at the sky and let it sing.
Right.
Yeah.
Yeah, it's beautiful.
Thank you.
Golds and blues and wonderful.
This is my Andromeda. This is the biggest print I've ever done. I have a print of this one. I think it's 12 feet by 8 feet. It's a really, really big print. But that one's actually going to get auctioned off to support the telescopes for kids here in the area. And, it's that sort of thing, but people love Andromeda. I do. I'm still fascinated by it every time I see it.
Sure.
So, but that one is just, that was actually shot from a light polluted sky in San Diego, California. So, you can do galaxies from light pollution, although a lot of people don't think you can. It's a lot harder. You have to do a lot more imaging to get the signal up, but it can be done.
Mm-hmm.
And this is the Trifid.
Wow. That is beautiful.
Thank you. Yeah. I didn't shoot this one for the longest time because it's literally right next door to the Lagoon Nebula.
Yeah.
And the Lagoon is such a powerful image every time you see it, it stands out in the night sky. It's one of the jewels of the night sky. It's kind of like Saturn for planets, you know?
Sure. Yeah.
And because this one's right next door, I ignored it for about 3 years.
Oh.
And then finally, it was my buddy, Travis Burke. He was like, "Hey, shoot that, man. Take some time and shoot." I was like, "I don't want to invest 30 hours. The lagoon's right there." And I finally did it. And now it's one of my favorite images. I absolutely love it. The color and the balance of the reflection nebula with the blue, with the emission nebula with the red. It's an unbelievable combination that's been produced naturally. And it's just, where else do you see it in such strong juxtaposition?
Mm-hmm.
You know, it really is an incredible nebula. And then basic stuff. I mean, this is the moon with a single image, less than a second, you know, through a Fujifilm camera.
Mm-hmm.
So people have done much, much better imaging of the moon, but the moon never gets old for me, man. If it's out, I'm staring at it, you know?
Right.
It just never gets old.
I agree.
It's one of those I still just very much love. And then M51, galaxies are really challenging for me. But this is one that I took a time, we did a live stream. I think I know you were there for the live stream with William, the 12-year-old that we let take his own image, and he chose the Whirlpool galaxy. And after he shot that and he just did so well, I was like, you know, I need to put some time into it too and try it. And he put in 20 hours as a 12-year-old. I put in 42 hours, and his image still absolutely destroys mine.
Really?
Yeah,
wow.
Absolutely.
But look at all the H2 regions you got in there. I mean, it's you know, the tidal forces that you can see going on. It is you know, it's really one of the remarkable face-on spirals that we can observe, and you know, but still very far away. I mean, it's what, 20-30 million light years away, something like that. And you know, I have and in my career as a kind of you know, more serious amateur astronomer, I've been able to see 2 supernova in this galaxy, you know, so it's just you know, that knowing that a star exploded all those millions of years ago, and we're just now getting the light, and it's real photons. It's not, you know, when you're looking at galaxies, this is not a reflection or you know, a copy or anything like that. The light that's hitting your eye is really photons that were formed in the cores of those stars, you know, and it's just, it's amazing.
Especially at this distance, there are no accidents. So when you see it, it's what you're seeing. And yeah, I agree. And if you're looking for a supernova, look at M51 and look at M101. They never disappoint.
Mm-hmm. That's right.
But it is one of the most, in my opinion, it's one of the most just exciting. I mean, you look at this, 2 galaxies that have collided and passed through each other, and one has ripped the arms off the other. It's just, it shows, you know, how both the organization of space and the chaos of it, at the same time, this duality,
and the power of it, right?
Exactly.
So,
the scale, if nothing else.
Right.
So it really is incredible. It's an incredible target. And then all the little faint galaxies in the background that so far away that when that light left, there were dinosaurs on the Earth. It's like, well, you know, it's going to throw me into an existential crisis immediately. You know.
No, but that does that to all of us, and you know, so you know, these you know, thinking about these things, that creates that what's, you know, I described it earlier, this cognitive shift. You know, Edgar Mitchell, you know, astronaut, really focused on this and tried to express this as I think no other astronaut did. You know, from his experience of seeing the Earth rise from the moon, and you know, the dude was changed, and he really felt that he needed to get the word out. And I think that you know, that was something that he was able to articulate very well, and he was able to inspire other astronauts to do the same, you know. But amateur astronomers get this too, you know, so it is, you know, you can't experience this kind of stuff and not be changed.
I agree. And you know, it never gets old, man. You know, I mean, you and I have had literally countless conversations about it, but you know, I appreciate so much what you're doing here. A huge fan of all of it, and
I'm a fan of yours.
you know, congratulations on 100. It's a testament to not only the vision for what this should be, but also the fact that you are truly a juggernaut. so thank you, man. I'm very
Thank
excited,
you,
and
Dustin. I feel like I'm
let
just
me
going
get out
for
of
the
everybody's
ride.
way. You've got incredible guests here. Let me get out of the way so everybody else can take this thing where it should go. But thanks for having me, man. I really appreciate it.
Thank you and good night. Thanks.
All right. Good night. See ya.
Yep. Okay. All right. So we are going to jump to Adrian Bradley. Adrian Bradley has been inspiring us for many global star parties with his nightscape images, his landscapes, his skyscapes. And Adrian, do you want to come on and show us what you got?
Yep. Can you all hear me okay?
We hear you just fine. Let me bring
All
you
right.
on.
Good. Yep.
Go.
I will I just had a long night because my goal for tonight and the morning was to get back out and do some night sky photography. I had been doing some couple of photography jobs recently and a number of other things. Things like playing baseball were getting in the way of seeing the night sky. So I had a clear night last night, and
you have to do all the things you love. So that's
right? Yep. So I wanted to do these images in order. It was my goal as I set out for tonight to capture some form of the planetary parade that we were seeing. So this would be it would be a from your eyes type of view, seeing all of the planets. So the goal was to do that, but first met up with the priest and said, I'm going to take a picture of your cabin, and got there, and as it so happens, found a couple of angles in which the rising Milky Way, found out there was haze. It's a cabin over the lake, and I was able to image some parts of the Milky Way. Now, for my priest, I also created this image where I have those of you that recognize the North American Nebula here in Deneb know that this is the Northern Cross. So the cross over his house, I figured I'd give him an image, a symbolic image. So that from there, I moved on to a beach and went to do some imaging there, and tried a couple panoramas. Because I knew I'd be shooting panoramas if I wanted to get all of the planets in a row. So I started to play around with doing panoramas. And once again, Bob, I know you're on. Some of the results I'm getting because of lowering the ISO to what I know the camera can handle and bringing up exposure in post has resulted in somewhat crisper images. Now from this, from a wide field, I used a lot of wide angle imaging, and I found that I could stitch together 2 wide angle images, and it made this panorama. So you've got kind of a broken a curve here in the Milky Way plane. But everything is there, and this is one of my favorite beaches to image from. No one's around. I believe the rocks are put here. They're basically trying to keep the water when it gets high from eroding this area here. It gets there used to be a bigger shelf, and it's fallen off lately. So they're trying to prevent it from doing any more damage, but it's a beautiful place to go and image. And then all of my friends in Canada, you're over here, and Port Huron is back this way. So after doing that, I then got up and went to the top overlooking that area, and one of these panoramas here is when the moon rose.
Oh, that's cool.
Yeah, this is
That
as
looks
I
like the
saw it.
sun, right?
That's actually not the sun. We'll get to the sun in a minute. The difference is in what moonrise and sunrise look like, because I
Right.
ended up staying out all night and catching the sun. So it looks like sunrise, but it's
Does.
not. You've got the Milky Way here still imageable, and here's Saturn, who made its first appearance, and there's Jupiter coming up through clouds and through haze here. Now let's see. I think I have another. Here's the moonrise as it appears to the eye. And you've got the shape of the crescent moon. This was an attempt to get it to look similar. Looks like it's on cardboard, but it was an attempt to get it as the eye sees it. So there's there'll be more work done there. Here we have Mars rising, and so what I did is I highlighted the planets a little bit in the image.
Yeah.
So you've got the bright moon, looks like the sun, and again we'll cover that. We've got Jupiter next to it, and we have Mars, we have Saturn. I think Neptune is in here somewhere. I looked for it in the sky here, but I wasn't sure. I may have it may be washed out by the moon. Pluto may be washed out by now, but considering I can still get the lagoon and the light from the Trifid here, and there's a star cloud. And actually M22, this is M22 where my hand is in Sagittarius. So, and the fog, this was true to life. What we see here, the fog over the lake, that was an interesting effect. And so I said, well, it's got about an hour left. Time just kept going. I had an hour left before Venus came up. So I waited, and then Venus came up, and then I waited for Mercury. During the night as the moon was rising, I pulled this shot where you had a boat that was coming in under the moonlight, and I think I missed it by a couple of inches as far as where I wanted it, but I'm happy with catching the moonlight and catching the boat. I thought that was a really interesting scene there. But then we went from nautical to civil dawn, and this image became an image basically showing the last vestiges of the planets as daytime is arising. So you had Saturn over here still, you had Jupiter, and again I highlighted them so that they would show up a little more in the picture. My attempt to composite the moon, we'll work on that some more. There's Mars, there's Venus, and then in the haze, Mercury appeared right here, just barely. And it would wash out maybe a minute later or less. And I didn't see this naked eye. This was after examining the photos and put together this panorama. So now you have these visible, just missing Uranus and Neptune. I was ambitious to think that I could somehow get Uranus and Neptune in here, but it's just too bright. And that's because the sun's coming up. So we'll review. Here's what the moonrise looks like. And here is what a sunrise looks like. Everything's gone except the dust on my sensor and camera, which I cleared some of that out. When the sun comes up, just about everything in the sky disappears, except today, you could see the moon and image the moon in the sky at the same time as the sun as it was coming up. So that was interesting. And this was, I'd hoped to have a better panorama of that, but I did capture some images where the sun and the moon are there at the same time. And let's see, I think I've covered all the images that I had. This is my usual in nod to your on the wing, Scott. I looked at this one and realized that I somehow, it was a fuzzy shot and I somehow caught some birds flying by.
You did.
So,
Thank you.
There you've got the moon, you've got some birds, and you've got the rising sun over here.
Perfect.
Supposed to be part of a panorama, but it ended up kind of being its own image over the lake. And of course, the lake changes looks too, as we went from night till morning, and the differences there. So, and then here, probably between this image and the other panorama I did where some of the planets are there, this is what I was going for. I actually wanted to include the Milky Way in this lineup. And I know it happens again tonight, but I started around 11 p.m. and over a span of 8 hours took all of those shots. So I've laid down and taken a nap earlier before coming on so that I could share some of the images. It was just nice getting back out underneath the stars and just enjoying my time, taking the images, looking around at the night sky, seeing what I could see naked eye. Enjoying the fact that it's warm out. There was a high dew point, if I remember. Fortunately, I didn't have any issues with the lenses and didn't get much sand. I did have that dust on the sensor that I'll have to, it's either the lenses or the sensor, so I'll have to do some cleaning there. But other than that, it was a wonderful night out, and I enjoyed taking those photos and being back under the stars to take them. So
absolutely.
So Scott, I'll turn it back over to you.
Okay, all right. And Adrian, you thanks for bringing on all your amazing work, and look forward to your future stuff. You keep threatening to go to the Southern Hemisphere, maybe. If that's on the horizon for you, maybe next year or the next. I'm going to be working with Cesar Brollo and to maybe conduct a star party in Patagonia. So I think that would be a lot of fun. And if we do that, you have to go.
I will go. I will find a way.
Yes, I am absolutely ready all the time.
I'll come in camera ready. And
with Adrian, we can go now, no problem.
Yes, I probably could, but saving my pennies. I'll save some more pennies.
Yes.
That sounds it sounds like a good time, and definitely would look forward to that. We'll see.
Maybe we can get you
what
to
baseball or what other
Sure.
things gonna have to go on hold, because seeing southern skies is definitely, as I've said, every star party I've been on, seeing the southern skies is a goal.
Right.
Something that for you, where if you have the center of the Milky Way over your head in the zenith, this is, you can make magic. But every time you make magic, the pictures are amazing. One of these I write in our chat that I remember the beach of the movie Contact. When you do remember, in the end of the movie Contact from the book of Carl Sagan, a picture of a beach with the Milky Way is amazing, because I remember completely the landscape of the movie Contact.
That must be why I'm drawn. I love that movie. That must be why I'm drawn to that beach. I don't think I didn't make the connection, but now I do. So that's part of the reason that I keep going back to the beach. I just missed the Milky Way sitting above the water, but it's close enough where you can still catch it over the water and over the beach line, which makes for a nice serene image.
Yeah, yes. It's something that we when we go, I need to go to the North Hemisphere too, because I'm home to see, to watch, to take pictures of this another side of the Milky Way, and you need to come here to the Southern Hemisphere.
Well, I hear that if you go to
I can
Chile,
show you the exploding star at Carinae.
Yeah, look forward to seeing that just in the path of the Milky Way.
Yes,
I hear that if you go to Chile, you can go up to a high enough elevation to where you can see our Ursa Major.
Yes.
So that if making it to the Northern Hemisphere doesn't work, just heading to Chile apparently is the way to go. So that's one place. If I had indiscriminate funds, that'd be one place that I would visit just to see how that works. But Argentina, anywhere in the Southern Hemisphere is definitely on the list. So
yeah.
I look forward to that.
Yes, but
all right. Well, gentlemen, up next is young Conal Richards. His program Vast Frontiers is next. And Conal, it's great to have you on Global Star Party.
Thank you very much for having me, Scott. I'm really happy to be here.
Yes.
Well, for tonight, the theme of exploration and awakening, I've taken that pretty literally and cut my presentation in two, so to speak. The first portion will be personal and observational exploration, and the second component will be sort of the awakening to the scale of the universe that results from those observations. And you'll see what I mean by that. I'll go into a little more detail. But first, I'll share my screen. I have a PowerPoint here for you. Share this. Okay. Can you confirm that you're seeing that okay?
Yes.
Okay, wonderful.
Yep.
The cover image here I have on my title slide is one of my favorite nightscapes and star trails that I've taken. My trusty reflector right in the middle, some trees in the back, and then Polaris just hovering above that tree line with some stars swirling around. I remember that night I was taking that image. I'd taken some observations, and I was actually getting really frustrated because, as we know, astronomy can have its hiccups. And I recalled that the neighbors kept turning their lights on. I mean, it was 5 or 6 houses all around me from where I was observing in the backyard. And there was dew, there was noise. It just wasn't a great night for observing. And eventually things settled down. But by that point, I thought, all right, I'll just get my camera out and point it away from those lights and get some interesting images. And it resulted in one of my favorite nightscapes that really captures the beauty and inspiration of what we do. And speaking of capturing, I'll go to my first slide here. I understand it's a little bit bright, but it's these descriptions and sketches that I want you to see. So when I first got my telescope, I remember looking around the night sky and everything was so new and exciting. Jupiter, the moon, the planets, different deep sky objects I'd read so much about. But at that time, when I first got the telescope and was trying to share this experience with people, I hadn't started recording things yet. So a couple months went by and I decided to start my own astronomy journal, which ended up being in this 99-cent little notebook, like a notepad. And I just got down there with a pencil, and I have a couple of simple sketches here. You see the Pleiades over to the left, Neptune and Uranus down in the bottom left corner when I first observed them with binoculars, the first time I'd ever observed those planets. And this journal, as small as it was and simple as it was, documented some of my first experiences in this hobby and enabled me to share them with people. That was until I got a little more involved in the photography side of things and could share things through that medium. But anyway, you see I have the first observation up top is the double cluster in Perseus. I have M45, Uranus and Neptune in binoculars again. And these were all very early in the morning. They're my first kind of looks into what the night sky had to offer. And it was such this vast treasure trove of things to observe. I didn't really know where to start, but a couple of books and magazines and some advice from others helped me focus my efforts on some brighter targets. You'll see another picture here. This is from that same journal, a little bit later in 2017. And I have some more observations. The Beehive Cluster, Kemble's Cascade asterism, and NGC 752, which is part of another asterism. It's a small open cluster next to an asterism of stars that looks like a golf club. And it looks like this golf club is hitting this small ball in the sky. And it's a really fun target through binoculars. And I wanted to see what that would look like to share it with others. So here I have it sketched very crudely in the upper right-hand corner, just above my written observation.
Mm-hmm.
And later on, I got a little more involved in sketching and photography. But I do like looking back on these observations because it shows how I got started, and I recorded some of my experiences and how I felt and what I saw and what it was like. And again, the night sky just seems so vast, and of course it still does. But here I thought I was getting some kind of a handle on things. I thought I've got my binoculars out, my telescope, and I'm getting a good view of what there is to offer in the night sky. And later I found out that, you know, I was only scratching the surface, and to this day I still am, and happy to be doing so. And a later iteration of my astronomy journaling, I switched to a sturdier notebook. This is the one I currently use, the image that you're seeing now. And this is an observation from 2019. I was looking at some planetary nebulae during that month, and I got more involved in the things I was recording. So I have the same basic information, the magnitude, or excuse me, the magnification, the instrument I was using. But you can see in my description here, I was noting that I used an O3 filter on this planetary nebula and kind of trying to figure out what effect that had, what effects averted vision had, and comparing the earliest observations of mine to these in this journal in 2019, I can see how my observing skill had grown, and I was able to look a little deeper into the night sky. Some of these planetary nebulae may have eluded me first when I was just getting my first steps in the hobby. And at this point, I had a little bit better grasp of them. And I thought now that I was stepping out of the Messier catalog, some of the NGC and Herschel objects, I was really seeing what the night sky had to offer. And yet again, I was still wrong. Another image from that notebook. This is from an Astronomical League binocular program, the Binocular Messier program. And you can see in my notes here, I pointed my binoculars at the region of the sky in Sagittarius, the center of our galaxy, and I was looking at some of the bright nebulae there. M16, it was the first time I'd observed that, M17, some of these really beautiful, bright reflection and emission nebulae that I thought were teaching me more about the nature of our galaxy and the nature of others by extension. And as much as they certainly did teach me, I was still only scratching the surface. And this lesson didn't occur to me until later, which I'll explore in just a little bit. Closer to home is the planet Mars. I believe I showed a slide much like this, these same sketches last week, talking about the upcoming observation of Mars for, opposition. Syrtis Major is here, the southern polar cap. There's some clouds or some frost in the Hellas Basin, a little bit more south. South is up in this sketch. And this sketch took me about 2 hours to make. I was really trying to squeeze every bit of detail out of that planet that I could, and getting as in-depth a look at the night sky as I had available to me with the instruments and experience I had. And at this point, I was certainly a more experienced observer, but there's always more to learn and always more equipment to build on your current collection, as I'm sure you all know, that's a familiar feeling. And this, going back to some very simple naked eye observations, this was for another Astronomical League program for observing Earth orbiting satellites. Of course, very close to home, maybe 300 or 400 miles just above the ground. And on the left here, on the left, I have a series of 3 satellites that I observed for various requirements in the program. At the bottom, there is a requirement for a multinational satellite series of observations. You observe satellites from a number of different countries. There's another one for observing a satellite that passes over multiple times in one night. And again, on the left here, you can see the names of these satellites and the countries of origin and their NORAD tracking numbers. Up on the top here, entry number 9 for that night is a Chinese rocket booster, the upper stage of a Long March rocket that was just orbiting the Earth And sometimes you'll see they might leak a little bit of propellant, or when they detach from their payload, they might have a spin exerted on them. And you can see those satellites brightening and dimming over a series of seconds as they pass overhead. So it looks a lot like a normal satellite. But the first time I'd seen something like that, I didn't know what to make of it, because it's a really rare phenomenon unless you start looking for it. But it's something I'd certainly suggest to many observers, even though it's going back to naked eye. You're kind of using your full range of instruments, including your own eyeballs, all the way up to a telescope. And then, of course, on the right here, I have the observation log that the League provides for that program. It shows how the satellite went directly overhead, and I have Cassiopeia there marked as a reference constellation for where I saw the satellite passing through, and then a little timestamp as well, plus some notes. And again, this is close to home, a little bit farther out. In fact, I'm sure we've flown quite close to these places, as the Apollo astronauts could attest to. This is a different observing log that I keep, my sketchbook, in addition to my written descriptions. And I started this during the opposition of Mars, the same sketch you saw earlier. And recently, these were just in a couple of weeks ago, back in May, I was looking at some different parts of the moon. I looked at that over a couple of different weeks. And again, this was for an Astronomical League program that required me to sketch some certain craters and features on the moon. And you can see up in the left-hand corner is Clavius there with its craterlets. And I'm sure many of us have seen and would recognize that crater. It's one of the largest on the moon, about 250 kilometers in diameter. But it was a simple sketch. And even over the course of a couple of days, I got a little bit better. Down at the bottom right is one of the most interesting features on the moon. It's a crater called Messier. And there's also a satellite crater called Messier A, you'll see over to the left here. And it's over towards the eastern limb of the moon. And it has this really interesting kind of ray system extending behind it. But you can tell that whatever impacted the moon at that time came in at a really steep angle, because there's all this sediment built up between Messier, the parent crater, and then its satellite crater, Messier A, and this ray system shooting out directly behind it, several times the diameter of either of those craters. And it does stick out to you, especially when it's close to the terminator, and that ray, that white material, the ejecta on the surface of the moon, is really steeply illuminated. That really pops out at you, and it's certainly one of my favorite lunar features. And I keep coming back to this. I'd explored many aspects of the night sky, many different objects, planetary nebulae, globular clusters, some of the bright nebulae in Sagittarius. Here I've observed satellites orbiting the Earth and these interesting features on the moon. And I keep pushing this further. And these were some much more recent observations at the end of May, and some of them at the beginning of June, for a double star program I was working on, sketching some double stars. It was something I hadn't really been involved in my just over 6 years in the hobby. And I thought that would be interesting to check out an object I didn't know much about. There's only so many objects in the night sky. It's certainly a vast array of categories, but this was one of those categories I hadn't really gone into much detail with observing yet. And this was one of those final categories of objects, like I said, that I hadn't gone into much detail with. And I was left thinking, what else is there to observe in the night sky? And the obvious answer is there's quite a lot. And I knew that intuitively, but I didn't really understand how that would really play out. So I used a program called Sky Safari, which is a really great program for cataloging your observations. And I like to keep a list, an observing list that the program lets you create of all the objects I've observed, both planetary and deep sky. So I was looking at the planetary observations, and it was really fun to see how some comets I'd observed, like Comet Neowise, Comet Leonard, were already out in interplanetary space. Some of them passed the orbits of Saturn and Uranus already when I'd observed them only maybe 2 years ago. And you can really get a feel for how fast those objects are moving, especially when you know that they're still in the fastest portion of their orbit because they're so close to the sun, and that they have much farther to go, and that some of those comets may never return to the inner solar system, or at least won't in this generation or for the next several thousand years. And that's a very hard thing to comprehend. And all of it is really quite hard to comprehend. But as I said, I also had a deep sky list, and the program lets you have this list and use a feature called Galaxy View. And it puts you in, it sets up two screens in the program. The top is a top-down view of the Milky Way, and the second is a side view of the Milky Way, or at least the sun. And it shows you the locations of every object in that observing list that was applied to the galaxy view feature. And this is kind of what it looks like. This is the very immediate neighborhood of our solar system, even at the vast distance of 1,000 light years. And you can see on the left here, I went up through the scale of distance of objects I'd observed. At this time, the closest object I'd observed, deep sky-wise, was Epsilon Eridani, which is one of the closest stars to Earth. It's about 10 light years away. And because of that, it's been the focus of many science fiction stories and novels that really captivated my imagination. And I thought I'd have a look at something that was so often included in stories of spaceships and interstellar voyages and all those kind of grand things. And then on the other side of things, the farthest object I'd observed, as far as I can tell, was Messier 109, which is a galaxy, a spiral galaxy, a little over 80 million light years from Earth, from our solar system. And you'll see that represented a little bit later in terms of scale. But here I have divisions of scale over on the left, and on the right, I'll have images from Sky Safari that indicate the objects I'd observed. You can see them indicated here. The white circles are stars or double stars from that recent program. And then the yellow circles indicate open clusters. And you'll see some of the other familiar map key features that we see in so many star atlases. But it looks like there's so much, and there really is, of all these stars in our immediate neighborhood of 1,000 light years. But when we step up to 25,000 light years, you get a much better sense for what the galaxy has to offer and what many other galaxies likely have to offer to perhaps some extraterrestrial observers looking around their whereabouts over there. You can still see there's plenty of open clusters here. There's a couple of planetary nebulae indicated by that blue circle with a cross in it. And these bright nebulae, as they're called by the program, they can include emission or reflection nebulae. They are the green squares that are on either side of our sun to the left and right. And you can see this is looking into Sagittarius. So this is probably M16 and M17, or maybe the Lagoon Nebula, probably some of those objects in the adjacent arm of our galaxy. And there's so much to see here. But the next view kind of puts that into perspective. It adds a lot more globular clusters, of which there are about 200 in our night sky, most of them in our Milky Way that we observe. But you can see that cluster in the previous slide that looked so broad and expansive is really tiny. It's really only a portion of the Milky Way, which is about 100,000 light years across. And I've really only observed around my arm of the galaxy in 6 years of observing. And this is what really hit me, is that with all those observations you saw earlier, all of those logs, those sketches, those written descriptions, that all applies to a very small subset of objects in our night sky. And it shows us that there is just so much more to observe. And there's so many vast frontiers out there that we have barely scratched the surface of and barely begun to understand. So even though, like I said, you can see so many globular clusters here and that cluster of closer objects like stars and open clusters to us, you can see a lot of the Milky Way is visible in this image, or at least the representation of it, because I haven't observed anything in those parts of the galaxy, and I probably never will, just because of the large distance and the limitations of our modern technology. The next scale I have set here is 5 million light years, and it shows some of our nearest galaxies. On the bottom image, in the bottom left, you can see M31 and its two satellite galaxies, its dwarf galaxies M32 and M110. And those are very close to us, about 2.5 million light years, I believe. And you can also see them represented in the upper image here. And there's just a couple of galaxies nearby to us, similar to our own Milky Way, roughly in terms of size and scale. But there's so much empty space between that. And again, even though there's not much there, it puts more of the scale of the universe into perspective. And I'll zoom out even further to 50 million light years. This shows most of the galaxies that I have recorded in the logs you saw earlier. Down in the top image, kind of towards the bottom of that image, you can see a huge cluster of galaxies there. That would be the Virgo cluster, looking straight up out of our Milky Way. You can see in the side view down at the bottom, it's quite far off. But of course, the Milky Way itself obscures many of the galaxies outside where we live. So it's easiest to look up to big clusters like the Virgo cluster if we want to get a better understanding of what lies beyond our own Milky Way and beyond our local group. So in this image, in this scale, it looks like there's this huge cluster of galaxies there. And of course it is. But again, there's so much open space. And within each of those galaxies, we see a vast, what used to be called an island universe of all those open clusters and globulars and double stars, and perhaps even people like us trying to look around and find out where their position in the cosmos is. So it puts both the scale of vast richness in our Milky Way and also some of the vast emptiness of the universe, both into perspective at the same time. I found that really interesting. And again, the reason this all hit so hard is I hadn't done an exercise like this until several years in the hobby. It was, I think, about 5 years into the hobby that I first looked at this feature. And I thought, well, I had, a little bit of ego there, thinking I'd seen all of this detail in our night sky, so many features on planets and satellites and moons, globular clusters, open clusters, stars, the Milky Way. I thought I'd seen it all, but I was really only just seeing the beginning of what the universe had to offer. And at my final scale, and again, this is just of my own observations, at 200 million light years, you can see just about every galaxy I've observed cataloged in here. And you might think if someone without a knowledge of astronomy were looking at this image, it kind of looks like that might be all there is to see. But we certainly know that is not the case. There are quasars like 3C273 that I believe are about 1 billion or 2 billion light years away, several times the scale of this image, the width of this image, or this rendering at least. The galaxies we were looking at earlier, the one Bob Fugate shared with us, that was 5 billion light years away, several times 200 million. And we know that as you expand outward, the shell gets bigger. And what I mean by that, if you look at a circle and the radius and diameter grow, the circumference grows even more. And that kind of represents how much there is outside of our knowledge. In fact, Einstein used a very similar metaphor when he was talking about what the adventure of learning is like. As you learn, that would be like the radius of the circle growing. You realize things that you don't know, and that would be the circumference of the circle. And that's growing at an even faster rate. And that's certainly the case with astronomical observations, both in the sense of personal understanding and also in the sense of cosmic scale. So as I go forward into the future in my hobby, I certainly hope to learn from others about what there is to see out there through professional telescopes and the experiences of others. And I also hope to push my skills and equipment to their very maximum and keep seeing what the cosmos has to offer and keep expanding this list of red ovals of galaxies and yellow circles of open clusters as I continue to uncover what the Milky Way has to offer and what our local group and large galaxy cluster has to offer. And in several lifetimes, I could never cover all there is to see. Certainly none of us can. And I certainly find that to be a humbling fact, one of those humbling and character building experiences in astronomy that Carl Sagan talked about. But again, I come back to this joy of observation and all those logs and descriptions and sketches you saw earlier. It does bring me a lot of pleasure to keep observing the night sky. And even though you're not going to see it all, that certainly doesn't take away from the joy of understanding the scale of the universe. So I hope that's a lesson that many of us can share and enjoy. And thank you very much for having me on. I appreciate it.
Wow, thank you so much, Conal. Yeah, you're always very inspiring. We were all talking about your journal that you keep. And Michael Carroll, who's up next, was mentioning it in our Zoom chat. He says, your journal reminds me very much of Galileo's sketchbooks. Great way to record and remember special night sky experiences. So yeah, that's great. Wonderful.
Yeah.
Conal, thank you very much. I hope that we see you also on the 100th Global Star Party. So
I appreciate it. I'll be there and at Alcon as well. So
great.
Hopefully our schedules line up.
And I'll see you at Alcon
at last.
Yeah.
Wonderful.
Wonderful. Thanks, Conal. Take care.
Thank you.
Okay. So last but not least is space artist and science fiction author, Michael Carroll. Michael, thanks for coming on to our program. And what have you got in store for us tonight?
Well, thanks for having me. First, publicly, I want to thank Scott for his flexibility. I had an impromptu visit to the dentist today, and we weren't sure when I would fit into this whole thing, but he's been great and was able to put me in this time slot, and I appreciate that, Scott.
Thank you.
So let me just do a little screen sharing here. 'Cause it full screen. See if this will work here. Okay, can you all see that?
Not yet.
Uh-oh. Okay.
Yep.
What does this mean?
Share
I
screen.
think
the
there may
green
be one
button.
more button to push. I
Yeah,
think you're
that's
almost
right. You
there.
got to commit to it.
Oh, there we go. Okay, let's see if this works.
Okay, looks like, yep. Okay,
There we go.
good.
Okay. There. Are we immersed?
Yes, we
Okay,
are.
here we are. I love the theme tonight, by the way, exploration and awakening. When we look out into the cosmos and we look down at our feet at this planet, it is fascinating to see this a strange and wonderful chain of things that have come together to make the Earth that we know today. What's so great about this planet? Besides Philadelphia, of course. It's a great place to live, obviously. It is absolutely, and you shouldn't modify the word unique, but it is unique. We have not found any planet vaguely like the Earth, even in exoplanets. I'd love to talk about Earth-like exoplanets at some point. But let's look around on a cosmic scale first. This is, of course, the Max Planck map of the cosmic background radiation of the entire universe. But we can look at things on a universal scale, even small, on the quantum level. And we see some interesting balances. For example, the force of gravity is balanced. If it was a little bit stronger, all the stars that we see would be so large that they burn quickly. They burn inconsistently. If it's weaker, the stars would not be big enough for heavy elements to make rocky planets. Our sun is just right for us because of the gravitational constant. The strong nuclear force is another one of these that holds elements together. And if it were a little bit weaker, only hydrogen would exist in the universe. A little bit stronger, and those life essential elements like carbon would be rare. And of course, there are many, many other strange and wondrous things that appear to be tuned just to a critical fine amount so that we can be here. But let's take a look at a little bit bigger scale, the galaxy. Now, of course, the Milky Way is more a barred spiral, but you can imagine that we are out between two arms of the galaxy. And as they say in real estate, location, location, location is the most important thing. We are perched between these two arms. Further out, life-critical heavy elements are thinly spread out. And if we got in closer to the hub or inside an arm, the stars are packed together quite a bit. The radiation levels would be pretty high. By the way, the person who would be great to speak more about this is Dave Eicher, who has a wonderful book. If you haven't picked up his Galaxies book, I highly recommend it. So we can move on from galactic scales to the sun, a just right star. If it was the big stars are like big Hollywood stars. They are hot and bright and they die fast. If our sun was a bit bigger, it would burn quickly and not be around very long. If it was smaller, it would be cool, like a red dwarf. our sun is very, very stable. It doesn't blow out these big flares like small red dwarfs do. It's been around in a stable condition for about 4 billion years after its T-Tauri phase. And it's going to be around for another 4 billion. So don't sell your stock. Just relax. Things are going to be this way for a while. And of course, there's that all-important Goldilocks effect, or the habitable zone. We are right in the zone where there can be liquid water around our star. If you're in a little bit further, perhaps a little further than Venus, it's going to be too hot for surface water. A little bit further out and you get conditions like Mars. It's too cold for water on the surface, but we are in just that right habitable zone. Every star has a habitable zone where liquid water can form. We just happen to be pretty much in the middle, which is nice. Another thing that contributes to the way our Earth is and how nice a place it is to live is the company we keep, our planetary companions. As you know, outside of the orbit of Earth, and in fact outside the orbit of Mars, there's a whole bunch of rocks, space rocks, asteroids, and they want, because of the sun's gravitational pull, to come in toward the inner solar system. And of course, we are right in the way. But there's a big gravity source disrupting their orbits outside of Mars, and that is Jupiter. In fact, Isaac Asimov once said something to the effect of, the solar system is made of the sun and Jupiter and a few miscellaneous things. Jupiter is by far the biggest, heaviest planet, and its gravitational pull preferentially tosses things toward the outer solar system rather than letting them come in. So in effect, it makes a force field around the inner solar system, which is pretty handy. Another thing that helps us to be the way we are is the molten core that we have. Our core consists of a solid core and a molten part. The molten part sloshes around and generates a magnetic field. And this bubble, of course, leads to aurora as it funnels energy down over the poles. And this is a protective shield for life on Earth from solar radiation. Another thing that the Earth has that we just don't find anywhere else in the solar system except really at Pluto is we are essentially a double planet system. The moon is so big, it keeps our axis stable. If you put a top on a child's top on a table and spin it, it's going to kind of wobble. This is called precession. If we didn't have a moon, we would precess the way Mars does. In 50,000 years, Mars is going to be rolling around on its side. And you can imagine what that does to the seasons, but not us. We have a stable spin because the heavy moon keeps us from doing that. The moon raises tides, which mix the ocean water, oxygenates things, purifies them. And there is also some new work that indicates that the moon may well have pulled a lot of greenhouse gases away from the early atmosphere. The Earth has had several atmospheres, but its second major one had a lot of greenhouse gas, and the moon may be responsible for clearing some of that out for us. Of course, the Earth is a jigsaw planet, and the plate tectonics are responsible for all kinds of wondrous recycling. We have the water cycle, which recycles water, but the plates recycle not only minerals, but atmosphere. Out of volcanoes, we get carbon dioxide, water vapor, nitrogen, other things. And that stuff floats around and it tends to chemically be locked into the rocks so that you get, for example, carbonate rocks from carbon dioxide. If this stuff sat around long enough, the atmosphere would all get soaked up by the rocks, or it would be blasted away by solar energy. But instead, what happens is the plates move, melt the rocks, free the gases, and it comes back out through volcanism and other sources. So if you're breathing today, thank a volcano. To know what would happen without plate tectonics, just look at Mars. Mars had volcanism, active volcanism, maybe for as much as 2 billion years, but it doesn't have plate tectonics, at least not now. It may have in the past, there's some evidence of that. But what happens now is that carbon dioxide, while it initially kept things warm, it escaped to space or got locked in the rocks as the oxygen did. Mars is a rusted planet. So we can be thankful for the plate tectonics we've got. And of course, the atmosphere gives us a shield against meteors and some types of radiation. So just looking out around us at the universe gives us an appreciation for the way this place is. We have just the right star. We're in a good place in the galaxy. We're in the habitable zone. We've got that shield against asteroids. Our moon is big. We have tectonics and volcanoes. And there are those forces throughout the universe that seem to be balanced. So hopefully this inspires us to explore more. I love exploration and what it does to us and how it teaches us not only about the universe, but about ourselves. Hopefully it will inspire us to take care of our unique planet and take care of each other. So thank you very much.
That is a nice way to wrap this particular Global Star Party up. I am, I've been really contemplating quite a bit about, this gratitude. I try to evoke a sense of gratitude from the moment I wake up. The first thing I do is I look out my window to see the sunrise, and I take a deep breath, realizing, the complexity of the gases and stuff that we breathe, and just to kind of feel, without losing that moment of how special life is, and just really the incredible, miraculous confluence of all the things that are going on, that just allow us to wake up, be conscious, and to take a moment to take it all in, and then just move forward, to explore that day, whether it's just what would seemingly be a normal day, but our lives are anything but normal. It is really amazing and special. And, at every moment you can see creation and destruction happening, and the whole recycling of life happening all around you. And it is magical. And, so that was the point of this particular Global Star Party, but I think it's the point of every event that we try to put on, and we try to add some of these aspects. And I love that all of our presenters today really brought it on and made each presentation really special in that way. So thank you very much to the presenters. Thank you to the audience that's watching from around the world. And, as my friend Jack Horkheimer always used to say, keep looking up, because, every moment's, another day, another moment of discovery and exploration. And so We'll be back with the next Global Star Party, our 99th on July 12th, and then our 100th, which will be on July 19th. And we'll continue to do more Global Star Parties past that, of course. It's nowhere near the end, because these things are very special. And if any of you who are watching would like to participate on Global Star Party, please contact us at explorealliance@explorescientific.com, or just call customer service. We're happy to get you on. We have had several guests who have watched our programs participate in Global Star Party. So it's a great opportunity to brush up your presentation skills if it's been a while. If you've never done it before, it's a lot of fun, and we always look forward to astronomers and what they have to present. So that's it. It's a wrap, and thank you very much. And here, I'll bring everybody on that's in our gallery right now. We still have Deepti in Nepal, Adrian's up there in Michigan, Cesar down in Buenos Aires. Michael, where is it that you live again?
There. I'm in Colorado.
You're in Colorado.
Yeah.
And Bob, you're in New Mexico, correct?
Yes, I'm in Albuquerque.
Albuquerque.
So I may run into you at Alcon.
Oh, I hope so. I hope so. I hear that Apollo astronaut Harrison Schmitt is going to be there. And so we're going to try to interview him at Alcon as we do some of these live presentations. But love to have you spend a few minutes with us too, Bob. So, and anyone that's attending Alcon, please come up and identify yourselves, and it'll be great to talk to you. And so that's all I have for tonight, folks. But thank you so much. And
I should probably mention I'm from Michigan, and most of my images are from there.
Yes.
It goes from the light polluted cities, the Detroit metro area. The further north you move in Michigan is where you begin to see some of the beaches and the lakes.
The Upper Peninsula up there.
Yeah, from the upper part of the Lower Peninsula, or the Thumb area, all the way up to the Upper Peninsula. It gets beautiful and almost as dark as New Mexico, but not quite. Out west in the United States is where some of our truly dark skies are, there in Florida.
Right.
Well, you should come visit. We have a couch.
The image behind me is from from Okie-Tex, an image that I took out there in Oklahoma. Colorado, Arizona, Bob, you in New Mexico. Those are all places that are on the list, and the list keeps growing thanks to Global Star Party.
Thank you so much.
I gotta go make more money here. I can travel.
Good enough. All right. Take care, and thank you very much. Thank you.
All right. Good night, everybody.
Good night. All right. Good night, everyone. Take care and get a good rest. We'll see you next week as we broadcast from Caltech and Mount Wilson Observatory.
Good night, Scott.
Good night.
Good night.